Welcome to Cloud Study Jam on Air, live from Google Cloud. My name is Brian, and you're watching the introduction session for our infrastructure-focused study jam this week. This study jam has been specifically tailored as a workshop for attendees interested in the Associate Cloud Engineer certification. If you're not sure if this is right for you, you can also tune in to our Professional Cloud Architect sessions, which are available this week as well. Both will be available on demand. You can ask questions at any time by submitting them in the box below this screen. We have Googlers on standby to answer them. Let's get started. My name is Brian Rice. My job at Google as head of Cloud Learning Portfolio involves driving the learning resources we make available to our customers and partners. But enough about me. Let's get on to the fun. Today's session, I'm going to tell you about three main topics. I'm going to explain what the Cloud Study Jam series is all about. I'm going to tell you what you can expect from this session and also from the rest of today's study jam. Finally, I'm going to dive deeper into the training and certification that will give you the tools you need to scale cloud infrastructure effectively and access on-demand infrastructure. First, let's get started with finding out what a cloud study jam is. Cloud study jams are study parties. They're for technical, hands-on practitioners who want to advance their Google Cloud skills. Join us during Cloud Next on Air for a curated selection of Google Cloud learning resources. You can hone your skills and further your cloud knowledge by becoming familiar with the resources available to you. You can follow along with guided hands-on labs and interact with Google experts. Now let's dive into an overview of today's study jam. Today, we're going to get started by giving you an overview of today's sessions, and we're going to use the time to talk about the most common customer need that has to do with cloud infrastructure. I'm going to tell you how you can help solve it using a wide variety of learning options that are available to you both this week and also thereafter. Coming up, expert Googlers are going to walk you through not only getting free access to Quick Labs, our hands-on learning platform, but also giving you a step-by-step tour of two infrastructure labs, Cloud Monitoring Quick Start. You'll have an opportunity to ask your technical deep dive questions here. Later on, you'll learn more about the Google Cloud Associate Cloud Engineer certification, including what it can do for your career, its benefit to your organization, tips and tricks for preparation from our certification, how best to start the certification journey. Now let's head on and talk about solving infrastructure problems with Google Cloud. The main problem customers come to us with has to do with scaling cost effectively in the cloud. They want to be able to access on-demand cloud infrastructure and resources. To solve this problem, you need to know what Google and re-platform your applications. You'll want to know about Google Cloud's approach to infrastructure modernization. The courses that we're going to talk about in this sequence teach you about implementing, deploying, migrating, and maintaining applications in the cloud. And throughout the whole journey, you'll get hands-on experience. Google Cloud's approach is based on offering a broad variety of resources, including a broad family of virtual machines. This allows you to tune your virtual machines to different workload requirements, including GPU access for workloads that need it. Google Compute Engine virtual machines are really easy to provision and to change and to scale up and down. Google Cloud also offers the easiest place to run Kubernetes in the cloud, Google Kubernetes Engine. Google Cloud's infrastructure is flexible. You can flexibly size Compute Engine virtual machines and Kubernetes Engine clusters. And you can independently configure CPU and memory to fine-tune the balance of those resources for your applications. Google Cloud pioneered per-second billing and offers other pricing innovations like committed savings, automatic discounts, reservations by zone, and storage lifecycle management. Google Cloud offerings are easy to understand and easy to use, so it's easy to get started and adapt as your business changes and scale as you grow. Google Cloud's reliability is based on the same infrastructure that Google is to support 8 products with more than a billion monthly average users. This infrastructure is what makes applications running on Google Cloud as secure and fast and reliable as possible. Google Cloud is constantly innovating, and our innovation is your innovation. As Google Cloud products improve, so do yours. To gain Google Cloud infrastructure skills, here's our recommended learning path. It's the sequence of on-demand training courses, self-paced labs, and other resources like the study guide for each of our professional certifications and sample exams so you can gauge whether you're ready. Our learning paths culminate in a professional certification that recognizes your cloud achievement. In the course of our session today, we're going to walk you through one of the preparatory steps for getting a professional certification, completing a skill badge, which means that you've done a sequence of hands-on labs and you've passed a challenge lab in which you demonstrate your skills in a timed hands-on environment, which is a great way to develop confidence going into a professional certification exam. There are plenty of opportunities outside of this week to continue your learning journey. You can earn skill badges, including getting free access to hands-on experience using Quick Labs. To learn more, go to cloud.google.com/training/badges. To see the full variety of professional certifications offered by Google Cloud, go to g.co/cloud/get-certified. Stay tuned to start your learning journey.
Welcome. You're watching What's Next? Associate. My name is Magda, and joining me today is Henry, Tristan, and Sven. You can ask questions at any time by submitting them in the box below this screen. We have Googlers on standby to answer them, so let's get started. What's next? Associate Cloud Engineer Certification. My name is Magda, and I'm the Global Lead for Google Cloud Certification and Credentials Services here at Google Cloud. And let's take a look at our discussion today. First, let's review certification benefits. Then, let's talk about learning resources and Google Cloud certifications. In the next section, let's review some certification success stories with our guests. And lastly, we'll wrap up with some additional resources. So let's start with certification benefits. We are really curious and interested in asking our community what is the benefit and impact of achieving Google Cloud certification. And we are very happy to report that 78% of certified individuals who participated in this survey, they report that they feel more confident in their professional future. 82% can prove cloud skill competency to recruiters. 83% feel that their resume is more attractive. And then finally, 85% feel more confident in cloud skills. Looking at other benefits, by achieving the cloud certification, you can distinguish yourself with a Google Cloud badge and a certificate. You can showcase your success on your social and professional networks of your choice. You can also network and exchange ideas in the Google Cloud certified community. And lastly, special recognition at select events applies to you as well. What are some of the benefits of certifications according to IT decision makers? So first of all, an interesting data point, how in the past 12 decision makers were dedicated in order for the team to prepare for a certification or recertification. When it comes to the certification value, 93% of the IT decision makers surveyed agree that certified employees provide added value above and beyond the cost of certification. And then lastly, 63% of IT decision makers say that the economic benefit of certified employees exceeds $10,000 a year. So right now, let's review some of the learning resources and our Google Cloud certifications portfolio. So first, here at Google Cloud, we really acknowledge that everyone learns in their own way. Different modalities work better for one person versus another. So we have this robust area of modalities for you to choose from, starting with the instructor-led training, and then followed by the on-demand training that you can access at any time in this video format that you can study. Then a very important format in the cloud space is the hands-on labs learning, where you can practice with Google Cloud technologies with the help of labs. And some of the labs completed by a challenge lab these days can result in you earning a brand new skill badge. And then finally, our Google Cloud Certified program that provides a benchmark for skills and proficiency on a job role level. So as I said, our certifications are proficiency and role-based exams that provide a benchmark for success. Specifically, here is our overall portfolio of our exams, and today we focus on our Associate Cloud Engineer certification with the recommended 6+ months of hands-on experience with GCP. So you may ask, what is the scope of the associate level certification versus the professional certification, for example? So I really wanted to highlight how in the overall customer implementation project, we may think and talk about business requirements side and the technical requirements. So in terms of the technical requirements, we speak about team members who build, deploy, manage. So this is really the scope for our Associate Cloud Engineer certification. In the professional certifications, the even bigger focus is on the business requirements. So for the scope of ACE, the certification we are reviewing today, the scope is mostly around the technical requirements in the overall customer implementation project. So you may also be curious, what are some of the learning resources that would be helpful to get started on the journey towards preparing for this exam and gaining the knowledge and the skills to really be successful? So over here, we highlight the path for you. You'll notice the on-demand training that's available, some of the self-paced labs, including our new skill badges, as well as other additional resources, including the Associate Cloud Engineer Study Guide, as well as the practice exam. You can find all these resources listed on our training website, as well as the direct certification website. Another resource I wanted to highlight is the official Google Cloud Certified Associate Cloud Engineer Study Guide. So this is, if you'd like, the actual book or the ebook to support your learning. So let's talk a little bit more about the Associate Cloud Engineer job role. So the Associate Cloud Engineer deploys applications, monitors operations, and manages enterprise solutions. This individual is able to use Google Cloud Console and the command line interface to perform common platform-based tasks to maintain one or more deployed solutions that leverage Google managed or self-managed services on Google Cloud. You can find this and more on our certification website. Specifically, the exams, as we said, are very practical. They're really designed for practitioners, people who can successfully perform in a given job role. So you may also be curious, what are some of these tasks that you would need to be very confident performing in order to successfully approach this certification? So the Associate Cloud Engineer exam assesses your ability to set up a cloud solution environment, plan and configure a cloud solution, deploy and implement a cloud solution, ensure successful operation of a cloud solution, and configure access and security. A little bit more about the exam. It is 2 hours long. The format of the exam is multiple choice and multiple select. There are no prerequisites, and we strongly recommend the practical experience with GCP. Another important information, specifically this year in the current times, we are delighted to let you know that this exam is available as the online proctored exam, available remotely. And please do make sure that you are meeting the testing requirements that are listed on our certification website to really be successful during this exam experience. And as with both in-person testing as well as the remote testing, I always highly recommend to booking the exam in advance to make sure that there is availability for the time that you'd like to approach the exam. And also a little bit more information about the recertification. This year, we have been extending the grace period for recertification. Our exams are valid for 2 years. However, you will find the extension of the grace period this year. So for the most up-to-date information about this, please refer directly to our certification website for the most up-to-date date of the grace period for recertification. So with that, I'm delighted to welcome our guests and chat about some of the certification success stories. So today with me, we have Henry, who's the strategic cloud engineer here at Google Cloud. Welcome, Henry.
Hi, thank you, Magda.
And Sven. Sven is Google Cloud engineer at Forecast. Welcome, Sven.
Hello. Hey.
And Tristan, Google Cloud engineer at Forecast. Hello, Tristan.
Hi, Magda.
So I have some questions for you. I would really like to hear what is your daily job? So what would be some of the projects that you are working on a daily basis? And if we could start with you, Tristan.
I work at Forecast. We're a Google Cloud partner, so that means that we implement solutions on Google Cloud for our customers. And I mainly work on big data projects. So what we try to do is we set up ingestion into the GCP environment and then help customers mostly leverage the data warehousing capabilities of GCP to help the people in their business gain better insights into their operations.
Excellent, thank you. How about you, Sven?
Hi. I also started using Google Cloud mainly for analytical purposes. For example, building a data warehouse in BigQuery, providing dashboards for the business with Data Studio. But now I'm also working more on the transactional part, where we use, for example, Firestore to be able to host a mobile application.
Thank you. And how about you, Henry? Tell us a bit about your daily job.
Sure. So as you introduced me, I'm from the Google Cloud Professional Services team. I actually lead a team of cloud engineers that help customers set up and run workloads on GCP. So the team that I lead and I'm a part of, we specialize in infrastructure. So we have specialists around Kubernetes, App Engine, Compute Engine, and we spend our days, our weeks, either helping customers move existing software applications into Google Cloud Platform or helping them design and create brand new applications on top of Google Cloud Platform. So a lot of the topics that are covered in the ACE exam are bread and butter for the team and are part of their daily lives.
Thank you. So today we talk about the Associate Cloud Engineer certification. Henry, what would be some of the most helpful preparation resources, or even more specifically, what was the preparation journey for you for the exam?
Yeah, so for myself, I found especially useful our Coursera courses that were available online for self-directed learning. They were super helpful because I could take them in my own time. I could watch them between meetings. I could also block out half a day and just get as many of the modules done as I could fit in. So I preferred the ability to self-drive and do it when it was convenient for me. Folks on the team also benefited from actually attending some in-person training, typically delivered by our cloud training partners. So we have those sometimes available to us within the company. And they found those super helpful because you get to interact with a trainer, you can ask them questions, you can go deeper on topics that interest you. But besides the learning material that's out there, the most critical thing is just getting hands-on with GCP. So what I encourage folks on the team to do and what I found super helpful myself is looking and actually deploying applications. So setting up a three-tier application, deploying the web app, deploying and the schema for the database and actually making it work and configuring it all on GCP. That hands-on experience will definitely help you be confident and pass the exam and obtain the certification.
Excellent, thank you. Sven, how about you? Any other insights about your preparation journey for the exam?
I would say that the documentation, the online documentation that Google provides is very extensive. There are always quick starts, how-to guides and tutorials available. But for really a track for the certification, it's good to follow the study guide to know which steps you need to take and which topics you need to cover. And then at the end, when you feel that you're prepared, it's a good idea to take the practice exam so that you know what kind of questions might be asked. And this way you can go confidently to the exam.
So a question for you all. How would you encourage someone new to the cloud engineering field to set a goal of achieving a certification? Sven?
Well, the good thing about getting certified is that you have a clear overview over all the different services. Because if you need to solve a problem, there are many ways to solve it within GCP. You can either go for fully managed services or into self-managed services. And if you know the benefits and the advantages of the one, and you know the difference and the similarities, and if you've learned all this, then you feel confident that you can take the right decision. So that's a big benefit of getting certified.
So, Henry, how would you encourage somebody brand new to the field to get certified?
Yeah, so I think I would approach it in a similar way. I think look at it as a confidence building exercise. A lot of the topics that we cover in the Associate Cloud Engineer exam and certification are pretty fundamental, I would say, to becoming competent in using Google Cloud Platform. So I think it's a great way to, by setting that goal of obtaining certification and locking in that exam date as you suggested, it's a good motivating factor. And then you can work backwards using the study guide to understand like where your gaps are and what technologies you should go a little bit deeper on. And I think that feeling of having the confidence that you've got that baseline of understanding is usually a good motivator for someone to really put aside the time and study the technology.
And how about you, Tristan? Any other points that could be useful to really encourage somebody new to get certified?
Yeah, so as mentioned, of course, it's very good for a personal confidence boost, but also it's a kind of representation to the rest of people you're interacting with, so your customers or whoever, to kind of show that you have experience with Google Cloud Platform and you know the different tools. So that's, of course, a very big added benefit to show that you have actually learned something because you get the certification.
Thank you. So, what would be some of your top tips to successfully pass the Associate Cloud Engineer certification, Sven?
I think that hands-on experience is very valuable. Like there might be some questions about like some G-Cloud commands. And if you've written those yourself, then it will stick much better in your head. Whereas if you just read it, then you might switch around some things. So I think that, like Tristan already mentioned, the Quick Labs are a great tool for that. They set up an environment for you, and you can really use Google Cloud. And I think that that's a big benefit and a good tip to use.
Excellent. And how about you, Tristan?
Yeah, so I think Quick Labs is a great one. I would also suggest if you're doing Quick Labs to actually not just copy paste everything around, but really try and write everything yourself. That really helps ingrain it a little bit more. And then I think going over to Coursera to get these like broader overview types of presentations from the GCP experts is also a really nice way to quickly get an overview, to go a bit broader than just the specific quick labs you're focusing on.
Great, thank you. So, Henry, I have a few questions just for you right now. So, in your experience, how does Google approach infrastructure with its customers?
Okay, so it's obviously a very big question. We definitely start by understanding their requirements and understanding the problem that we're being asked to solve with them. So I think it's absolutely fundamental that we have a shared and clear understanding of what the goal is and what the technical and non-technical requirements are before we jump into determining what the right solution would be. So once we have that understanding, then it's about looking at all the different options that are available. And I think this is one of the kind of advantages, but in some ways, it can be a disadvantage that there is so much options on GCP and so many right ways to build something. So in order to really choose which approach is appropriate, you do have to fall back to those requirements that you spent time gathering at the beginning. And then it's not simple, but it's a decision-making process of what are the high-value solutions that we can put forward that are low cost for the customer to implement. And when we think about low cost, it's not just in terms of the price for that product, but low cost in terms of the implementation costs, either from their engineers or from their partners, but then also the ongoing operations costs. Often we overlook that. We look at just, how much does this product cost to use and how long will it take us to implement it? And we don't think about and how much effort is it going to require to maintain that solution. And sometimes, when we look at, those ongoing costs for maintenance, we can start to look at, do we make an investment upfront to actually educate ourselves on a new type of technology, which would require less effort for us in the long run to maintain and extend and operate in the future. And I think that's why it's really important to spend the time actually getting certified and to understand the tooling well, so that you can have a very educated discussion about what the trade-offs are between different choices. And that's why one of the reasons why certifications are actually a compulsory thing within our team, to make sure that we all have that baseline of understanding. So once we've gone into that kind of decision process, understanding the requirements, addressing the solutions against that criteria, then it's the fun part of actually, collaboratively building that solution together with the customer.
Excellent. Thank you so much. So with regards to the exam, the ACE exam, all domains covered in the exam would be available in the certification guide. And I'm curious, in your practical experience, what are some of the core technical concepts that you would say are really key to understand in order to approach this exam?
Yeah, I think the key thing, which I kind of alluded to earlier, is really getting hands-on and actually using those products in a practical way. So if you have a trivial use case at the company you work for, or perhaps there's an open source application that you like to use a lot, maybe it's WordPress or something else, I think take the time to actually try and deploy that application on GCP. And using that certification guide, you'll get a good overview on the different kind of technology choices that you have to choose from. And you might like to think about, how would I take this app and deploy it on top of something like Kubernetes? Or how would I take this app and deploy it on top of Compute Engine? And I think going through that exercise and trying to set up that application, it will leave you in a very confident position, and you will have had a chance then to get your hands dirty with those different products in a very practical and relevant way.
Thank you. So, what value has Abide had on your career here at Google?
I think it's provided me value, I guess, in two ways. At the very beginning, it was super helpful because it set a clear pathway for the different things that I needed to learn in order to be successful in this role. So looking at the certification guide, not just for ACE, I know we're talking about ACE today, but also some of the other certificates, the professional level, and also some of the specializations around DevOps and networking, looking at what those learning pathways were, provided a clear pathway for myself to, deepen my knowledge on Google Cloud Platform. And then, as I mentioned before, after I obtained those certificates, it was a real confidence boost because I then felt comfortable that I knew I had the baseline understanding of what those products were and how to use them, so that when I met with customers, so that when I started proposing solutions for customers, I had a solid body of kind of learning and certification to base my my guidance on.
Thank you. And congratulations again on your achievements in this area.
Thank you.
So some questions for you, Sven and Tristan. What was your motivation when you decided to take the Associate Cloud Engineer certification? Sven?
Well, at Forecast, we really have self-development and lifelong learning are a really important part of our culture. So our manager also really encourages us to take those exams because we were a premium Google Cloud partner, but we also need to we need to prove this, and we need to show our customers that we are capable of providing those solutions. So that's why we have this learning track. That when we start, that we have those courses on Coursera, and they really encourage us to take the certification exams.
Thank you. How about you, Tristan? What was your motivation?
Yeah, so for me also, I really just like learning new stuff. That's also one of the reasons why I actually joined Forecast. Because a cloud platform that's really, it's quite new, relatively speaking. So in university, that's not really something you get in touch with a lot. So that's really, it was something quite new for me personally. And it was a nice challenge to really get to know the ins and outs, and also to be able to compare it to other cloud platforms, because that's something that a lot of customers also come to us with. It's not, they haven't always already decided to go full GCP. So really being able to compare all those services is a very useful benefit from taking the certification exam.
Thank you. So how much time did it take for you to prepare for this exam?
It was around 1 month. That was really like going full focus on it, with some like side projects to as you get to a point where you really have a good overview of all the tools that are at your disposal. So
Thank you. So Sven, what value has being Google Cloud certified had on you in your time at Forecast?
You really have this self-confidence when a customer asks for a problem and you need to provide a solution. You're able to compare all those different services, and that you can show them an architecture that might work, and then you can discuss this with your colleagues, and you just have the knowledge to provide this and to create those solutions within GCP.
Thank you. And how about you, Tristan?
Yeah, so of course that's a very good one, that upfront, like knowing all of those services. But really, to me also, I see it as some like a daily challenge. You often get like a small thing you have to solve, and then it's really important that you can quickly see, okay, this is something that service is very useful for. Like it's a very simple, just some kind of proxy. I can use a cloud function, for example. That kind of stuff that you try to make day to day. That's where, and gives you confidence that you're actually choosing the right service as well.
Henry, Sven, and Tristan, thank you so much for joining us today and sharing your insights with our audience.
Thank you, Magda. It was great to be on, and good luck to everyone when they take their certification exams.
Yeah, thanks. Very nice meeting you all, and had a great time and nice, fun sharing experiences. So thanks.
Thank you very much, Magda. It was very informative. I hope that we can encourage a lot of people to take the exam.
All right, so let's cover additional resources as we close our session today. So start your journey to Google Cloud Certification today. We do have a campaign with the learning paths clearly outlined, and you can join a cohort of other candidates, learners to study with. So just select your path. You can learn anywhere, anytime. And as we mentioned for the Associate Cloud Engineer, you can also take this exam remotely. So visit the link g.co/cloud/certify to start your journey. We have a special offer today. This is an exclusive offer of a 50% discount of the Associate Cloud Engineer, Professional Cloud Architect, and Professional Data Engineer study guide. So please visit wiley.com and use the promotional code to use your discount. And we hope to see you for our remaining weeks of Next. So join us weekly to expand your expertise with engaging learning sessions, hands-on labs, and live technical sessions with Google experts. Thank you so much for tuning in today. Please visit cloudonair.withgoogle.com for more hands-on learning, training, and demos from Google Cloud experts. And see you next time.
Welcome to Cloud on Air, live webinars from Google Cloud. My name is Corey Peel, and you're watching a hands-on lab session for our infrastructure-focused Cloud Study Jam this week. Coming up, we have a few slides on cloud monitoring, and following that, we'll have a lab walkthrough using Quick Labs. You can ask questions anytime by submitting them in the box below the screen. We have Googlers on standby to answer them. So let's get started. So with cloud monitoring quick start, we're going to be tackling some problems some of you are really used to, because if you are in DevOps or a developer or a site reliability engineer, usually you need to understand what's actually running. Is it up? If you have some events you're expecting and maybe they're missing. So you have a need to be able to monitor your applications. And with Google Cloud Monitoring, we'll talk about how you can do that on Google Cloud. And we also support, again, other clouds and even our on-prem hybrid connectivity. So I'm Corey Peel, and I'm a customer engineer with Google Cloud. And today's agenda is going to focus on three things. So first, we're going to dive into cloud monitoring. What is cloud monitoring? And this is, again, a part of our cloud operations suite. Next, we'll talk about how you get access to the hands-on labs. So with these cloud study jams, we have a great environment for you to really get hands-on experience with Google Cloud using credentials we're providing you. And then third, we're going to do a demonstration of our cloud monitoring quick start lab. And it'll be great for you to join along. So let's get started. So first, what is cloud monitoring? So when you're monitoring, the main focus is observability. So what are you observing? You may have application logs, system logs. There might be metrics. Sometimes these are based on some of the logs, and you're using that information to define metrics. In other cases, you may have something that might be a bit more application specific. And then you also have application performance monitoring. When you're looking at the way applications are running today, they can be fairly complex. And so it's not as simple as just being able to look at maybe just a single log file. Or when you're looking at the performance of your application end to end, you may have microservices or a lot of different pieces. And so what's really an easy way for you to see all this in one place? So with Google Cloud Monitoring, you have the ability to have observability at scale. So this means we can look at not just hundreds, but thousands of instances in various environments and really be able to give you the information you need to make a decision to either scale up or to correct an issue. Next, when we're focusing on just monitoring itself, we are putting in place something to give you the best out-of-the-box cross-signal integration experience. So this really means we can have all the different pieces of your applications come together and provide the type of information you need to make your decisions. This is possible because we are focusing on an open platform. So by leveraging an open platform, you can connect with a wide variety of system logs and applications, and you also allow a broader community to really expand and provide additional integrations. Also, when you're able to have the cross-signal analysis between logging and monitoring, you can do really interesting things, such as understanding when do you have a missed event. So if there's a daily activity or something you really need to see and it's not there, that's sometimes a little bit harder to detect than just getting a lot of alerts when something is wrong. So really putting that together gives you a really good way to have a single pane of glass to look at what you are putting together and what you are expecting to provide to your users. We are also building monitoring based on the best practices of Google's own site reliability engineers. So when you are thinking about how to scale and work on these applications and understand what's really happening underneath the hood, our monitoring systems are really designed to make that possible, because again, we have complex environments ourselves. We need to have insight at scale. And so next, we'll talk about out-of-the-box monitoring. It is possible to just turn on monitoring in less than a minute. Now, those of you who've been in DevOps roles or SRE roles in the past, you might have many different systems monitoring different types of applications or different parts of your system, and you need to get access to all of those different pieces to get the right level of visibility across the board. And so it usually takes a while to get things set up for that full end-to-end observability. But with Google Cloud Monitoring, you have out-of-the-box monitoring. So this is really easy, and you can really just create a project and just wait for that workspace to be set up. And we'll be getting into some of the quick start features when we get into the lab. So next, we're going to talk a bit more about dashboards. So I know some of you might be living in a space where you have multiple monitors and screens and you have all these dashboards, but what's really important is the ability to bring the information to you in the way you expect it so you can make the right decisions and take corrective actions. And so we have a lot of interesting features in our dashboards. So you can actually filter and group at the dashboard level, drill down into specific metrics. And this also lets you have the type of functionality expected by our own SREs and also our Google Cloud Customer Reliability Engineers. And next, we're talking about metrics. So the Metrics Explorer build ad hoc charts based on metrics. So we may have system metrics, but you can also explore and really understand what types of metrics are really available to you. How are you going to be pulling that information together to get the right type of insight? So you can visualize 100% of these metrics. And this includes third-party metrics. Not only what you have available out of the box from a system and application standpoint or platform standpoint from Google Cloud, but also with some of our partners. And again, if you are in a multi-cloud environment, the ability to see the same applications deployed on Google Cloud and also on other cloud providers, it makes it very compelling. So again, the ability to be really ad hoc and then define what metrics you want to see. Now, one thing that's very common for almost every application is an uptime check. So because this is so common, instead of having you to really build out something custom all the time, we are providing functionality for the most common types of uptime checks. So when you want to monitor your application, your users are able to see the same thing you're seeing with this uptime check. So it could be from an HTTP server or other types of interactions. So you're able to maybe do an HTTP GET just to see what's happening with that application. And also, not just application standpoint, but if you have maybe managed instance groups or others, you're able to do this at different levels. And so you can also set up and really have some periodic API requests, because again, we're providing you with like the most common, really basic uptime checks, but to really understand the health of some of your services, you will likely need to have interactions with some of the other APIs and endpoints. And for those who are working with Kubernetes, Google Kubernetes Engine, GKE Monitoring, has been really enhanced in the latest release. and the ability to have comprehensive observability across the board. This works again with GKE, but you also can integrate with Prometheus if you're using Prometheus as well. So having this unified solution for monitoring your Kubernetes environment is extremely useful, and this also would extend to our Kubernetes on-premise environments as well. And when we get to service monitoring and service monitoring best practices, this is really where we get into some of the maturity and experience coming from Google's SREs. So you may have your SLIs, so the service level indicators are really metrics that are used to define your SLO targets, so SLO for your service level objectives. And so the planning process for people really working on this now tends to be focused on defining your SLOs. And the things that are more of the binding agreement, where you have your service level agreements, this is where you're able to see end to end what you are putting together, so you have the best end to end service monitoring. So it's not enough to only objectives that may be higher that you may be able to reach, but your SLA is defined at a certain point, and you can have some of the indicators available to understand your objectives. Now, moving on to alert management. So this is very interesting because it's useful, but sometimes you may feel like you're getting so many alerts, you just need to figure out what's really important, or are you getting repeated alerts for maybe the same event? So alert management is really intelligent because it lets users set up alerts so you can be notified when incidents occur. But we also have integrations with some of the common channels and other communication tools like Xmatters and Slack and PagerDuty. So you can have alert management really integrate with the way other teams tend to work. So if you need to put up one of your virtual war rooms, you are making sure the right people are getting those alerts, and users can set up alerts in a variety of categories. And so the ability to aggregate your thresholds, but one in particular around metric absence, these are these different types of alerts we're making available with our operations suite and with cloud monitoring. So now we're going into the second part of this session, where we'll talk a little bit about getting access to this lab and also to other labs. So with this context you have right now with cloud monitoring, we'll talk a bit about Quick Labs and what are you doing with Quick Labs? So Quick Labs is actually a hands-on learning environment, and this gives you a sandbox to work in, so you're not working on your own environment when you're trying to really learn and test out some of these features. So it gives you really practical, hands-on experience using credits that are Quick Labs credits, and not really spending your either credits or spending your funds on some tests from a learning standpoint in your production environment. Next, we'll talk to the people who are not waiting for later, but if you want to follow along live, we have a really interesting opportunity for you to join in our Cloud Hero game. So this is the ability to play along with other people who are doing the same labs. And so you can play with other attendees and complete quests together. So if you join the Cloud Hero game by August 4th, then you can find out where you stack up. And if you look at your Quick Lab settings, you can have a different display name than your regular name. So feel free to express yourself and make sure you are participating in the game. And again, it's a lot of fun. So in order to get started, you will be able to go to the to the links provided below, and you'll be able to get started with the description. And then if you are registering with with not just with Quick Labs, but with Cloud Hero, this slide shows, again, going to our short URL, goo.gle/ch-next. And this will let you see the Cloud Hero game for our next on-air activities. So again, go to that link. Again, it's google, so goo.gle/ch-next. So just take a moment if you're following along and go there and get set up. Okay, great. So now that you've signed up, we can talk about what the game is doing. So the actual game itself is, again, a part of the Quick Labs environment, and it's a collection of labs. So you have labs relevant to this week's theme. In this case, we'll be focusing on some of the cloud engineering infrastructure types of labs. So now we're going to go to the third part of our session. And this is when we will get into the lab demo. So I'm going to go to my lab environment. And in my case, I'm using a Pixelbook. So I've logged into my Quick Labs environment, and I'm looking at my screen where it's the Cloud Monitoring Quick Start. Now, before you click on Start Lab, just orient yourself a little bit on this page. There's a bottom right side, there's a little chat bubble. If you run into any issues accessing the lab, or if you have other types of questions, there's a chat to support with Quick Labs support. So just remember, if you have a question or something happens, you want to get some assistance from the infrastructure side for Quick Labs, go to that bottom right bubble. So now we're going to talk about the lab and the lab environment. So going into Quick Labs, so you've already logged in into google.quicklabs.com. And when we're logged in on this page, before you click that Start Lab button, let's just take a look at what's here. Because once you start that lab, that timer begins. And when the timer ends, your access to resources will end as well. So let's just take a look at what's available here. On the bottom right, we have this blue chat bubble. If you have any issues or questions related to the operation of the Quick Labs environment, you have, again, access to chat. So feel free to use that if you run into a problem. Now let's take a look on the left side. We have a couple of student resources. It's about 5 or so videos on YouTube, just to give you some background of what you'll be seeing in the lab, and maybe a bit of a refresher if you didn't go through the full presentation. And then finally, we have the Start Lab button. And when you start the lab, you will have credentials provided to you. So besides the link to the Google Cloud Console, you will have a username, password, and a project ID. Those are the ones you will be using for this lab. You will not be using the credentials you have for your own Google Cloud environment, or even the credentials you use to log into this Quick Lab. On the right-hand side, we have the steps we'll be completing. So today, again, we're taking some time to just review this setup. We will create a compute engine instance and deploy an Apache HTTP server. This is just so you have something to work with, because you don't need to have a fully functioning application. Right now, we're focusing on just really understanding how to get into the monitoring environment, how to create an alert, how to create an uptime check, how to create dashboards, and really view logs. So we're going to be using a simple HTTP web server. Going to start lab now. Reading some of the details here prior to starting the lab, so you get some more background on what we're showing. So again, as we discussed in terms of the setup, we talked about what you do before you start the lab. And then here, we're just going to follow. On the left-hand side, we make this really easy to copy, so you can just click to copy. And then now we're just going to paste. And now I'm going to go back. We're going to be toggling back and forth a little bit here, looking at the instructions. And then we will agreements. The project ID. You want to initially sign in. Do not sign up for free trials or anything else. We're providing a menu on the top left. You may toggle the navigation menu on and off. So now let's go back to the Quick Labs instructions. So to create a compute engine instance in the cloud, we're going to go to the compute engine section and then click VM instances and create. But I also want to look at the, so I can easily paste that when I'm entering in the fields. So let's go to the Cloud Console, go to Compute Engine, VM Instances, and this is to provision Compute Engine instances on Google Cloud. Right now, we're just going to I also could have used the search to search for add compute engine, and I would have a shortcut to do that as well. So now I'm in the create an instance page. And so I'm just going to put in this name, and it's a permanent name. So make sure you have that name pasted properly so the validation will work. And then the other fields, I'm going to select region. So I can pick either US Central or maybe Mumbai. And then machine type is N1 standard 2. And then there's a firewall rule. I'm going to allow HTTP traffic because, again, I know the lab I'll be setting up an HTTP server. So let's go back to the Cloud Console. So the region is already on Central 1, so I can leave that. one standard 2. So I've selected that. And then as I scroll down, traffic. And now I'm going to click the server to the instance. We access the instance by clicking SSH here to connect. And then afterwards, there are a couple of commands I'll be running. So I'm going to go back to the Cloud Console and go to this step to open up SSH. And as I'm connecting, it's automatically exchanging. But I'm going to copy the command so we can grab the HTTP server. And then now I'm going to go back to the instructions. And here, if you run into any issues with PHP 7, you can always use PHP 5. So I'm going to do the command with PHP 7. And do I want to continue? I will say yes. And so now, as I go back to the instructions, the next step will be to do a restart. So again, some of you may prefer to type out some of the short commands, but feel free to copy and paste. But it is important to realize that you should understand what's going to be processing and not just paste without reading. So here we're going to restart the Apache server. Okay, and so now we've gone through the process. We have Apache server. Let's see if it's actually working and running. So we're going to go back here into the Apache, where I've deployed the Apache server and the instance is running. And it says here to click the external HTTP, the external IP, and this will bring up the default page. So I see that I've done that. And again, the green checkbox will confirm you're on track. Now, we just completed that first part of it where we were creating a compute engine instance and we created an HTTP server. So now this is really a scenario where you have an application or something running and now you want to monitor it. So the next step in the process will be to create a monitoring workspace. And then after this, we're going to go through and configure some of the things you want to see there. So the next step will be to go back to the console, into the navigation menu, and then go into monitoring. I'm going to close out this HTTP default page. And if I click on the navigation menu, I did have this bookmarked. So it was pinned already. And so I'm going to wait for this workspace to build. So this is our cloud monitoring environment. Some of you may be familiar with what we used to refer to as Stackdriver, but now we actually have a broader definition for our Cloud Operations Suite portfolio of products. And so this is setting up the Cloud Monitoring workspace. So this will take a couple of minutes. So I'm going to go back to the Quick Labs instructions and just look at some of the things we'll be doing next. So while we're waiting for the workspace to be provisioned, we'll see that we'll be able to look at the monitoring environment, and there are 3 key tasks here where we'll install agents. So again, a logging agent and a monitoring agent. Then we'll be defining the uptime check, in this case for the HTTP server or the VM instance itself. And then we'll be creating some alerting policies, and then there'll be visualization. So let's just go back to the monitoring dashboard and see if it's done provisioning. Okay, so now we're done, and we can see these different options. So right now we don't have any incidents, and there's some default rules that are there. So again, we don't have uptime checks defined yet. This is what you get by default. So feel free to explore and learn more, because this will bring you to the documentation pages. Now I'm going to go back to the quick start instructions, and now we're going to read this a little bit so you understand what's happening with the next steps. Because we have agents collecting data and then sending the information into cloud monitoring. So with cloud monitoring, we're able to collect system logs, application logs, streaming logs. And so this agent is going to be pulled from our repository here. And so we'll be grabbing the agent and then installing the agent. And then you will next, after you finish it for the monitoring agent, you'll do it for the logging agent. So our next steps after this will be to go into the window. So we already have that open with our with SSH. So let's go back to the instructions here, and we're going to copy the settings to install the agent. So let's copy the command here to install, and we're going to say yes. And after this has been completed, then we have the monitoring agent installed. Then we're going to go to the logging agent. So again, going back to the shell here, we're going to install the logging agent. And so now we're done with that part of the configuration. So, so far, after deploying the compute engine, the HTTP server, we then placed agents on that environment. So the VM instance currently has 2 monitoring agents running, one for monitoring and one for logging. Next, we're going to do an uptime check. So we're going back to the Cloud Console this time. And in the Cloud Console, in the left menu, we're going to create an uptime check. And now let's just take a look at the next part of the instructions so we can see what the name should be. So I'm just going to copy the LAMP uptime check title. And here I'm going to go to uptime checks. Again, I could do it from here as well, but we're going to go to the navigation menu. And then we will create an uptime check. And now we have the title, which will be the right title for validation. And then let's scroll down for some of the other settings. So this will be HTTP, which is one of the for instance, and it'll be single. So again, with our VM environments, we can have managed instance groups, or we can have a single instance. And then we have the name. So we'll leave path at the default, and we're checking every minute. So let's go back to the monitoring console and configure these settings. So HTTP, that's set. Resource type is instance. Here, we're just selecting single instead of group. We have lamp. We're leaving the path empty. And then we're checking every minute, so that's already correct. And then we're checking log failures. So let's just review what this says here. That was selected by default. Okay, so our screen looks like that now. And then now we're going to click test to verify we can connect. So let's test here and see if we have a response. Yes, we have a good response. And then we'll save. Okay, so now we've created an uptime check. Let's go back to the instructions and just verify what we're doing. So after saying save, we'll just click no to creating an alerting policy for this check, because we're going to be doing another type of policy for alerts and not for this uptime check here. So we'll click no thanks. And as you can see, this was set up as a global uptime check. You have the ability to define what this is if you want to do it for just certain locations. So let's go back to the instructions. So at this point, you have the compute engine, you have the HTTP server, and you have the agents deployed, and you have an uptime check available. Now we're going to use cloud monitoring to create an alerting policy. And this is going to be named an inbound traffic alert. So I'm just going to copy the name. And we'll go back to the cloud, click on alerting, create policy, and we'll paste the name here. So with the alerting policies, we have the ability to add a variety of conditions. This is very useful because you can check if a service is unhealthy. You can trigger different policy violations, but also doing things such as checking for the absence of activity can be useful. We are going back to the instructions to review what conditions we should put in. So in step 3, to add condition, we're going to open up the panel and we're going to create a condition for the VM GCE instance, so Google Cloud Compute Engine instance. And this is going to be a type for network. So when we type in network, it's actually really important to look at what it says here, where it says the network traffic resource is related to this agent API. So I'm observing this. I'm going to go back to that first step here where I'm just going to go to the target and type VM. So let's go back to the alerting policy. And then we'll go to VM instance. And then let's just confirm we are going to have the resource type VM GCE instance, metric type network. So when I type network, there are a couple of options here. So I want to make sure I'm actually getting the ones from the agent metrics. And as you can see, we have a few different options, but this is the one I want. Okay. And so now let's just take a look at the settings, where we're going to look at the configuration for the condition. So here we're going to look at the threshold. So we'll say threshold above 500 for 1 minute. So going back to the Cloud Console into the configuration. So if any time series violates this condition above 500, that will be the alert. Okay, so now we have the condition for the alert and we've added it. Next, we'll define our notification channel. This is really flexible. You can use a lot of different notification channels. For you to validate this test, you can put in your personal email address so you receive the email and view it. However, if you are following this lab, we're going to actually remove this email notification channel later on. So don't worry, it's not going to be there for a long period of time. Also, you may feel free to just create a separate account just for this test. We just don't recommend using the account you're using for this lab execution. So we're going to click on notification channel, email, and then I'm going to put in an email address for testing. So notification channel, email. Let's do a test email. Okay. And now we've added that. And let's toggle back to the instructions. For documentation, I can add a message, but I could also use Markdown. So again, in this case, I'm just going to just say alert. And I can preview what it looks like. And then we'll save. And so now we have our inbound traffic alert. So let me check my progress here, and I see that I've created the uptime check successfully and the alerting policy. So now we're going to create a chart because we have the monitoring for uptime, we have an alert. So let's take a look at the possibilities of what we can put in the dashboard. So in the left menu, we're going to select dashboards and then create dashboard. And again, I'm just going to copy this name so I can easily paste it for validation later on. So going into the console again, clicking on dashboards, and then we're going to create dashboard, put in the dashboard name. Okay, and so now we have an empty dashboard. So let's go back to the instructions and we'll add the first chart. So on the top right, we'll see add chart, and we'll call this one CPU load. So going back to the console, we'll add a chart, CPU load. Now what's interesting here is we also have the ability to use queries and other functionality, but the instructions told us to type CPU load. So we're just going to do that. But feel free to explore the other types of metrics available here. And we're going to do CPU load for 1 minute. And I'm going to go back to the instructions just to verify that's the one. And then for set resource type, it'll be VM instance. Clicking on VM instance. Okay. And now let's go back and see, okay, that's it. So we'll click save, and then we'll go to the second chart. So now you have a dashboard with a chart with the CPU load. Now for the second chart, we're going to call it received packets. And as you can imagine, these charts are based on the uptime check and the alerting policy respectively. Well, not just the uptime check actually, but the alerting policy and some of the metrics we saw earlier. Let's go add chart. Received packets. Okay. And then when we go into the field, we're going to select received packets GKE instance. And received packets. We should have this for GCE. And let's make sure we have the right one, GCE instance. There it is. Okay, and I believe that should be it, but let's just verify. GCE instance, and then we'll set the resource type to VM instance, and the rest will be the default value. And we save. Okay, so now we have a dashboard with charts. We have a lot of other functionality here we're not reviewing in this lab, but feel free to just explore. So before we go back to the instructions, I'm just going to go into the Metrics Explorer, just so you can view different types of metrics. We also have the services available. So again, when we were describing defining a service, and then you're planning around SLOs. Again, we have some other examples related to this. But let's just go back to the dashboard, and now we have this dashboard available to us. So going back to the instructions, now we're able to view logs. So we've set up the dashboard. We have our metrics, some of these other the uptime checks. So log viewer and view for the LAMP instance. So I did pin logging earlier to make it easier for me. So I just click on log viewer. And it is alerting you to let you know which project you're viewing, because some people may have a lot of projects. And so let's just take a look at the VM instance for LAMP1, and we see the information in our log now. So this is in our operations logging environment. So going back to the instructions, after we selected the LAMP1 instance, we could click on the Start Streaming Logs icon, and then we'll be able to view our logs. So let's just take a look here, Start Streaming. So now we'll see the streaming logs we're actually getting from the logging agent. Okay. Here, going back to the instructions. So the next thing we're going to do is we're going to take a look at what happens in the log when we maybe stop the engine and do some other things in that environment. So we're going to open up the compute engine window in a new browser window. So let's go to the right here. We'll click and we'll just put this in a new window. And this is actually just to make it easier to have the logging side by side with the compute engine when we're viewing some of the instructions here. And I'm also going to toggle off the navigation. So now, when we're doing the review, so what we're going to do is look at the compute engine console on one side, the logging console on the other, and in the compute engine window, we're going to click Stop at the top of the screen. And of course, this is going to impact our uptime check. So we should see information in our logs about this uptime check. So let's just go here into the instance. Okay, and I'm in this smaller view, so I'm just going to click the menu here and click Stop to stop the instance. And now I'm going to navigate from the instructions screen into the log viewer screen. And so while this is stopping, let's just go, and what I'll do here, I'll bring this out to make it a little easier to see. So in the logs, we're going to see some updates. And so one of the things we're doing here, as I'm going to wait for this to complete, once we have the down, also be able to see what's happening on our dashboard, because we did create a uptime check on the dashboard itself. Okay, so now we're refreshing the log viewer. And we want to just refresh this so we can see in the logs that with the uptime checks, we're still trying to access a server, an unavailable server. Streaming logs again. Okay, so we see the shutdown event. I'm going to, again, move this side to side. And so going back into the instructions, so this is that we saw that it stopped. Now, after we notice it stopped, we're going to actually restart this engine again. So start, and after starting, the uptime checks will actually be working again. So let's go back. And actually, I'm going to click here and just go back to log viewer in the full view just to make it a little bit easier to see. Okay. Now let's start streaming the logs again. And now I should see that the server is back again. So we see that it started. Actually, take a look at the uptime checks in monitoring. So in the logging, in the navigation menu, we'll go to monitoring uptime checks. So go back to the monitoring. And so after we get to the uptime checks, we should see a little bit of a delay. So we see that the last happens when the checks were passed. And then in addition to the uptime check, we also can check to see if the alerts have been triggered. I'm going to just click here on alerting. And indeed, I see that I have one alert firing, and it's the instant for this network traffic down for the quick lab alerts. And behold, I do have alerts related to this instance coming into the email. We're actually at the end of the process. So there's one part we have to do before we shut down, and that's to make sure we remove the rule with the notification. My policy. I'm actually removing it from the policy and not the full channel itself. And then we will save. Done with the lab. And we were able to go through, do a configuration where we've deployed a compute engine instance, added Apache HTTP server, did an uptime tech, an alerting policy, have some dashboards with charts. We viewed the logs, and then we actually forced the uptime check to be triggered when we shut the server down, and then brought it back up. And we got the email notification in addition to the incident on the console. Really follow and understand how we were able to leverage Google Cloud Monitoring in a really easy manner, because after you create that initial workspace, it's just a few clicks before you just start monitoring your application. So now we've wrapped up the demo. You were able to learn a bit more about cloud monitoring. You put together the we're going to see what's next. So after completing the lab, this is really exciting because now you've completed one of the lab's skill badge quest labs. So these Google Cloud skill badges are a way for you to get hands-on practice with Google Cloud. You can share with your network. So to explore more about skill badges, go to cloud.google.com/training/badges. Thank you so much. Investing in training yourself.
Infrastructure-focused Cloud Study Jam. You can ask questions anytime by submitting them in the box below this screen. We have Googlers on standby to answer them. Let's get started. Hello, welcome to Week 3, Infrastructure, Hands-on Lab Session 2. This is a Cloud Study Jam, where we walk you through no-cost training on Google Cloud. This session is on the infrastructure track, and today I'm going to walk through an infrastructure challenge lab. I'm also going to drop a few pro tips from our advanced lab creators for improving your scores. These are proven tips to help you max out your scores in our weekly Cloud Hero hands-on lab games. I'll tell you how to join this week's game a little later. I'm Mike Trudy. I'm the Technical Curriculum Lead for Infrastructure in Google Cloud Learning, and I'm Google Cloud Professionally Certified, or certifiable, a few times. In this session, first, I'm going to introduce you to our baseline infrastructure quests, which you can use to explore our cloud infrastructure tools hands-on. Then I'm going to show you how to access our hands-on labs, so you can try one yourself, or follow along if you like. And finally, I'm going to walk you through one of our infrastructure challenge labs. Now, challenge labs are a little different than regular hands-on labs. In a regular lab, we describe features and then walk you through step by step to try out what you learned. With a challenge lab, you get assigned a series of end goals and an allocated time to meet the goals. There's no step-by-step instructions. A challenge lab is the last lab in a quest, and you need to use what you learned in the other labs to complete the tasks. Challenge labs aren't easy. To score 100%, you must complete 60 minutes. Did you know that Google Cloud runs on the same global infrastructure that powers YouTube, Gmail, and other Google products used by billions of people around the world? To get a foundational knowledge of Google Cloud, you should complete Quick Labs infrastructure quests, which walk you through hands-on practice with real Google Cloud resources and tools. There are 3 quests I like to start. The first one is the Getting Started Create and Manage Cloud Resources quest. In this quest, we introduce Cloud Shell, VPC Networks, Compute Engine, and Kubernetes Engine. Second, do the Perform Foundational Infrastructure tasks in Google Cloud Quest. This includes labs for storage, IAM, monitoring, Cloud Functions, and PubSub. Third, do the Setup and Configure a Cloud Environment in Google Cloud Quest. The challenge lab walkthrough that I'm going to do is from this quest. Real quick, I'm going to review the labs in this quest. The topics covered in the first 6 labs are going to be needed to complete the challenge lab. Lab 1 is Cloud IAM Quick Start, introducing you to identity and access management in Google Cloud. In Lab 2, Introduction to SQL for BigQuery and Cloud SQL, you learn some SQL and run queries in BigQuery and Cloud SQL. Lab 3 is about creating multiple VPC networks and using VM instances within them. Lab 4, Cloud Monitoring Quick Start, helps you start monitoring your resources for specific events. In Lab 5, you launch a service using Deployment Manager, full production, and you do some more monitoring with the service. And in Lab 6, you scale and manage containers by managing deployments using Kubernetes Engine. Finally, Lab 7 is the challenge lab, set up and configure a cloud environment in Google Cloud. And we'll get to that soon. Let's get into Quick Labs. There are a couple of ways you can get access to the lab we'll be demoing today. Now, if you're following along live with us, in week 3, as part of Google Cloud Next On Air 20, you can hop into this week's Cloud Hero gamified experience. The game is a week-long contest of curated labs relevant to this week's theme, with prizes. The lab I'm going through today is included in this week's challenge. There's a link to get started in the description of this video. The link takes you to a page with all of the Cloud Hero games for Next On Air. Find Week 3 Infrastructure and click Join. If you need to stop this for a second, don't worry. You can pause and keep watching later. Or if you want to focus on watching me or ask questions in the Q&A, don't feel like you need to log into Quick Labs just yet. Once you join the game, you'll see a screen like this, which says Week 3 in the title. If you scroll down, you'll see the Cloud Engineering Labs, and this is the quest I showed you earlier. I'm going to walk through the last lab, the Challenge Lab. We announced recently that when you complete one of these special quests with a Challenge Lab, you earn a Google Cloud Skill Badge. Google Cloud Skill Badges are a recognition you can earn when you complete Quick Labs quests with a Challenge Lab. You develop your skills, and you can share your skill badge on your social profiles or resume. Check out cloud.google.com/training/badges for more details on that. Now let's hop over to the Challenge Lab. And the way we get this started is we click Start Lab. Now this lab takes about 2 minutes to do some behind the scenes setup. So while it's working, let's just scroll down a little bit and look at the scenario that we've got laid out here. So we've got some topics covered, some setup, but this challenge scenario here, this is the meat of what we have to do in this challenge lab. 9 tasks, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have some company standards here. Our company standards require that we create all resources in the US East 1 region and the US East 1B zone, unless otherwise directed. We're going to use the project VPC networks that are created by the lab setup. And then if we have to name any resources, or resources are already named, they're going to use a team resource convention with a hyphen. Default to N1 standard 1 machines, unless we're otherwise directed in the task. And our challenge is sort of to set up an entire environment. And this is a pretty good architecture diagram. And I'm going to go ahead, what I normally do when I get an architecture diagram like this is I pop it into a new tab, and it's easier to see. But first, what we're going to do now that the lab is ready to go, we can go ahead and get started with the lab. So to do that, I'm in an incognito window, actually. You can see to the top right here. And the easiest thing to do is to log into Quick Labs in an incognito window. And then when you click Open Google Console, it should take me right where I need to go to get the project started. So I'm going to copy my username here to log into the console. And this is a Quick Labs user ID and password logging into Google Cloud. So I don't have to enter any billing information of any kind. I'm going to accept the student user account terms. I'm going to confirm the default recovery setup. Okay, this is the Google Cloud Console. I'm going to click Agree. My project is already set up here. It's the same project that Quick Labs assigned me here in this project ID box. So I'm in Cloud Console, and I'm going to go ahead and close out the menu there. So I'm actually ready to go here. A new drawing, and then I just give it some title, and I copy this image, and I paste it into here, and I try to make notes on my architecture diagram as I'm building the lab. So we'll come back to that. Okay, so if I go back to the lab here and I look through these, in summary, based on this architecture diagram here, our goal is to get WordPress application running, which means I need a Kubernetes cluster and a VPC and a database and in this case, a Bastion host that I use. So we've got some work to do to kind of step through all these tasks to get this WordPress application running in our dev environment. If I skip down here to task 1 and I kind of read through these instructions, I've got to create a VPC called dev VPC, which if you scroll up here on the architecture diagram, it's this big blue box with some subnets. The 2 purple boxes are the subnets. So I don't create networks all that often, and when I do, I usually use the Cloud Console because it walks me through the steps real nicely. So Griffin Dev WP. So if I kind of hop over here, I can pick VPC, VPC network, create VPC network. If I follow the instructions there, the name of the network is Griffin Dev VPC. I'm going to leave custom subnet creation mode here, and I got to create 2 subnets. The first one is Griffin Dev WP. We have to use region US East 1. And then we've got an IP range of 192.168.16.0, and that's a /20. And then we click done there. And then I think I've got to create a second subnet. So I'm going to say add subnet. This is for our management subnet. So I'm going to say Griffin Dev Management. And that's US East 1 also. And that's 192.168.32.0/20. And we're going to leave default dynamic routing mode, no server policy, no private DNS happening here. And we're going to click create. Okay, so that's going to take about 30 seconds. So we used Griffin Dev WP, an IP address block for each of these. And while we're waiting, what we could do, which I like to do, is hop over to the architecture diagram and kind of annotate my subnets. So 192.168.16.0 was dev WP. And then dev management is 192.168.32.0. And that's a /20. And that's a /20. All right, so we've updated our diagram. There's our VPC network with our 2 subnets. Let's go back over here and click check progress to see, task 1 complete. Okay, so one thing to note is we can run step and it'll give you a hint. In this case, it says we completed the assessment. So this is a little trick. A lot of people don't know it, but as you go through the steps, you might get some small hints by coming in here and clicking this if you're stuck on a step. The other thing that I should tell you is if you're completing this challenge lab as part of a game, your game score is based partly on your completion time. So finishing faster gets you a better score. If you want to improve your score on a challenge lab in a game, you can restart the lab and do it again faster. You can do this up to 5 times. Okay, so we're on to task 2. So for task 2, we got to copy some files from a bucket. And then we're going to run a deployment. Then we need to run a deployment manager script. Okay, so let's head over here. Let's open up Cloud Console by clicking Activate Cloud Shell. I'm going to click Continue. It takes just a couple seconds to open up Cloud Shell. My personal setup in Terminal is to change the font to monospace. and the text size to medium. I can read it a lot better there. Okay, so we're going to copy these files. Now, we did use GSUtil in the Cloud IAM Quick Start Lab, so I remember how to use GSUtil to copy files from a Cloud bucket. And there's another piece I want to show you here before I get to GSUtil, which is I sometimes forget the details of commands like gcloud and GSUtil. So I'm starting to use this gcloud interactive mode, but it's only in beta right now. So sometimes it does have problems. But I just thought I'd try that for a minute. And once this loads, you're going to see function key prompts along the bottom of my shell screen, along with little reminders of my project and user. As well as some possible help text. And the nice thing about this gcloud interactive mode is it helps me with my commands. So when I start to do task 2, they want me to copy some files. I'm going to use GSUtil, and you can see that it's auto-completing for me. If I hit tab, it kind of helps me. So then I hit space, and it's giving me the GSUtil commands that are options. This is really nice. So I'm going to do a copy, and I want to do all the files. So I do -R, and I'm going to grab the bucket that we had there. And I'm just going to copy that folder into my root folder. Okay, so now I can go look at that DM folder, and I've got one YAML and one Jinja file. And I know that in Deployment Manager, these are the template files that are used to create infrastructure resources. So if you didn't know, Cloud Shell has a built-in editor, and it's changed a bit recently, and I think it's pretty awesome. So I click Open Editor, and it's going to switch my view over to the editor view. And then the files that we copied are in this DM folder. So I'm going to go ahead and I'm going to start with the YAML file. And I already know that the region here is wrong, so I'm going to fix the region. And this little circle at the top tells me when it's saving. So when I change it, the circle tells me it's saving. Now it's saved. So then I can click over on the Jinja file, and I can see the details here are that it's going to create a prod VPC and then some subnets in prod for us. So I'm going to go ahead and copy paste these IP ranges into our architecture diagram. So this is prod WP subnet. If I come over here, there's the prod WP subnet. So if I just kind of paste that guy. And then this guy is a 64. Okay, so we're creating some documentation here as we build our project. Okay, that looks good. So let's go back to the terminal. And now we're going to use gcloud interactive to deploy that script. So we do gcloud. Here's deployment manager. That's pretty nice. And we need a deployment. And we're going to create. And I need to deploy. So it's prompting me for the next thing that I need to type. So I need a name. So I want to use Griffin Prod as my name. And then I'm going to point it at that config file. Here, and we expect that guy to create the prod VPC. So we can kind of watch up here on the refresh, see if something happens there. So we're trying to create the prod VPC and the two prod subnets, prod WP and prod management. So deployment manager is working. We can refresh here to see, oh, there we go. The UI's already got it. So we've got our prod VPC and our two subnets, and we'll just let deployment manager finish here. And we've got our three resources. If I hop back to the lab and I check my progress, the lab says we're good. Okay, we're on to task 3. For task 3, they want us to create a Bastion host. And a bastion host is usually a VM that has an external IP address that helps you get at VMs that don't have IP addresses. And I know there's some pretty good explanations on bastion host docs. But if I look at the architecture diagram right here, and it's actually connected across two VPCs, which means it's using Google's multi-NIC feature, where a VM can have two network interfaces at the same time. Remember from the multiple VPC networks lab that we did. So in that lab, we used Cloud Console because creating these VMs with multiple network in Cloud Console makes it a little easier for us. So I'm going to switch over to Cloud Console. And I'm going to do create in VM instances. And this is the new VM to create instances a little easier than it used to be. So I'm going to use a name. I'm going to call it VM Bastion. And then US East 1 looks, we did name the VM Bastion, and so I copied it. I'm just going to move it over to CP22 and IMP. So let's create that firewall rule. Now while that's happening, I can create the second firewall rule. That guy's allow dev SSH NICMP. That's the dev network. We're going to allow and they'll let us do pings. Okay, so this should be our two firewall rules. So let's give that a second and see how long it takes to create those guys. Okay, now I'm going to leave this as a public. And we're going to leave this. Okay, we can look at security features, but I'm just going to leave those as defaults. I'm going to go back and check out my command line. These are, you can copy these for your speedy game scripts if you want to do that. The bucket that the lab tells me to get them. Okay, and there's 3 YAML files here. Great. So let's see, we're going to need to add secrets, create a volume for WordPress, and there's a deployment config there for us to do that. So if I open the editor and I click at these WP, and there's actually this M YAML file. And in here, I need to replace a couple values. So let's see, the username that we want to use is WP user. And there's a password that we set earlier. So I think that's it for this guy. It saves by itself. I'm going to go back to the terminal. Now I need to access that cluster. So I'm going to click connect here. And I'm going to run something in Cloud Shell. And it's going to run this gcloud container clusters command, which is going to populate credentials in my Cloud Shell instance so that I can talk to that cluster. And now I need to get that key file created, which I'm just going to copy the instructions from here and paste them in there. And what we're doing here is we're creating a key from an existing service account, and then we're going to download that key file so that we can use it. And so now what we need to do is set up that environment with WordPress by applying the file we edited. So, okay, there's our interactive command being an alpha beta product. So let's close the terminal. Let's open again. Let's go back. Let's try that again without the interactive command. So we'll do q-apply -f wp env. Okay, so we've got both the volume claim and the secret that we said we needed using this kubectl-apply command. And I think that's it for task 6. So we can go ahead and see if we made it all the way through. Uh-oh. Let's see. Is there something here that needs to get... Okay, just a timing problem. So there we go. We've got our Kubernetes cluster prepared. We're on to task 7, create a WordPress deployment. Now we have a MySQL database. We've set up secrets in a volume. We can create the deployment using the WP deployment YAML. We've got to edit the file to replace the SQL instance and the instance connection name. And then we want to create a service. So we're going to create both a WordPress deployment and a WordPress service using 2 different YAML files. And the service is going to create a load balancer, which gives us access to our WordPress application. And then we'll actually be able to load up the application and see that it runs. So we've got to basically deploy the service deployment, the service, and then check that we can access the app running. Okay, so let's see, what are we going to do for that? We're going to go back to the Cloud Shell editor. Before we were working on M, this time we're going to work on this deployment. This DB host here needs to change to Griffin Dev DB. This DB user needs to change to WP user. This DB password needs to change. And then we need that SQL instance connection name. So I've got to go find that. It's right there. And I got to copy the whole thing. And it goes right here. Okay, and that's saved. So now let's go back to Open Terminal. We're in the right place, I think. So we're going to do this deployment. So we're going to do kubectl-apply the deployment YAML. And it says, now to see what's happening there, we cut back over to Kubernetes engine. And there's our cluster, but now we want to see if we created a workload. And there's our workload getting started up. Sometimes it takes a little bit for the workload to start. There we go. We're green. Okay. And now we want to deploy the service, which will create a load balancer. So this will take a little while, probably. Okay. And from services and ingress, we're going to wait for that guy to get started. So what did we just do? So to go back to the architecture diagram, we're in our WordPress pod. We've created a WordPress application deployment, which communicates through a Cloud SQL proxy to our Cloud SQL database, which we populated with a database and a user. And now our service, our Kubernetes service, is going to create a cloud load balancer with an external IP address so that we can access the application. So we're just looking for that external IP address now. So let's kind of take a look here and see if we can see. Oh, there's our IP address, and we can go ahead and see that it's open. There we go. We got an IP address. So I'm going to copy that. So we've got a WordPress app running. That's awesome. All right. I think we can check our progress now on task 7. There we go. So for task 8, they want us to create an uptime check to show that we can do some monitoring on this WordPress development site. So we know that we talked about monitoring and uptime checks in the Cloud Monitoring Quick Start Lab. So it's not that hard to do this, but it does take a little time. So we're going to click back over on the Cloud Console and open up the monitoring pages. And monitoring is going to take just a minute while it builds our workspace. So I'm going to go ahead back to my architecture diagram. And I remember I saved that IP address, and I like to keep those notes handy in case I'm going to need them. So I'm going to move that IP address right here. Okay. And setting an uptime check's not really that tricky. You just got to kind of know what your host name is, and we're going to use the IP address for that. And then you've also got a path that the uptime check's going to use, and we're just going to use this default page here. Now, we do have a new cloud monitoring Cloud Console workflow, so I'm hoping I get to use the new workflow to set up our uptime check. Let's see. So here I am in monitoring. I'm going to do uptime checks. And I'm going to do create an uptime check here. Oh, let's see. Okay, so this is the old style UI. So sometimes I get the new style, but at this time I've got the old style UI, which is fine. Okay, so the title we're going to use is Griffin Uptime Check. It's going to be an HTTP type of check. We're going to use a resource type of URL. We had that host name. We're going to use, you can use an IP address as your host name. So I'm just going to use this IP address as my host name. And then I'm going to grab that path off of WordPress here. So I'm just going to grab a path for the uptime check to hit. I'm okay with it checking every minute. I'm okay with all this, so I'm going to say save. Uptime check created. I'm not going to worry about an alert policy for now. Okay, so I should have an uptime check ready to go. I can do check my progress. There we go. All right, now we're on to task 9. So for task 9, they want us to add access for an additional engineer starting. We're going to grant them project editor role, and it'll be the second user account. Okay, I know how to do that. So this is an IAM and admin task. And I think this is from the Cloud IAM Quick Start Lab. So I grab this second user right here, and I go to Cloud Console, IAM, and I'm just going to add a user. I'm going to enter that email that I grabbed. And then I have to select a role, which for simplicity, we're going to do project editor. I think most projects are moving away from these project level roles in favor of more fine-grained roles that are task specific, like App Engine admin or BigQuery admin, BigQuery user, storage object creator, stuff like that. But for this lab, we're just going to do project editor. We'll say save. So now I have a second user who should be able to access all of our project resources. Let's check our progress here and see. Check. Okay, so let's just test this for fun though. So if I come back over here to our project, I should be able to sign in as that user and still access things. So let's try that. Let's create a new console. And I'm still logged in as that user there, so I got to sign out. Okay, so I'm going to grab this user here. I'm going to sign out. I'm going to sign in with another account. I'm going to do the second user. I need that password. Same old set of steps. I've got to accept terms and conditions. But now I'm a different user, and I would only be able to access resources in this project if I had some permissions. So let's see if I was able to do that correctly. Pick the project. And like, let's try, for example, there should be that compute engine. We can see that guy. Oh, there they are. We've got the Bastion host and then the cluster nodes. If we head over to Kubernetes engine, we can see our cluster, our workloads, and our service. We can still hit that IP address for the WordPress app. Everything looks pretty good. Okay, so we're done. We completed the lab, which means we should be eligible for a challenge for one of our skill badges. Because this is a challenge lab, we can now earn a credential. And if I look back at the architecture diagram that we kind of worked on, oh, I can't have access to it anymore, so I'll get to the one in the lab here. We can kind of recap what we did. The recap is, here we are. So we created a VPC with some subnets. We actually created one manually and one with a script. We created a VM instance here. We created a Cloud SQL instance with a database. We created a 2-node cluster. We deployed a WordPress app. We created some uptime monitoring checks right there. And then we allowed a second user access to the editor as an editor of my dev environment. Pretty awesome. Okay, so now let's go back to the slides. Oh, click End Lab. Now we can go back to the slides. That's it for the demo. I hope that was helpful for you to walk through an infrastructure challenge lab. Thanks for joining me. Check out the other sessions this week in Google Cloud Next 20 on air. And we're running more Cloud Hero games for the next 6 weeks. Next week, we'll be focusing on security. See you next time.
Welcome to Cloud Study Jam on Air, live from Google Cloud. My name is Brian, and you're watching the introduction session for our infrastructure-focused study jam this week. This study jam has been specifically tailored as a workshop for attendees interested in the Professional Cloud Architect certification. If you're not sure if this is right for you, you can also tune into our Associate Cloud Engineer sessions, which are available this week as well. Both will be available on demand. You can ask questions at any time by submitting them in the box below this screen. We have Googlers on standby to answer them. Let's get started. I'm Brian Rice. My job at Google is as head of Cloud Learning Portfolio. My job is to drive the learning resources that we make available to our customers and partners. But enough about me. Let's get into the fun activities for today. Today, we're going to cover 3 topics. First of all, I'm going to explain what the Study Jam series is all about. Second, I'll let you know what you can expect from this session and also the rest of today's Study Jam. Finally, I'm going to dive deeper into the training and certification that'll give you the tools you need to scale effectively and access on-demand cloud infrastructure. That's our game plan. Let's start off. First, let's get started with finding out what a Cloud Study Jam is. Cloud Study Jams are study parties for technical, hands-on practitioners who want to advance their Google Cloud skills. Join us during Google Cloud Next on Air for a curated selection of Google Cloud learning resources. You can hone your skills and further your cloud knowledge by becoming familiar with the resources that are available to you. You can follow along with guided hands-on labs, and you can interact with expert Googlers. Now let's talk about what we're going to do today in this Cloud Study Jam. I'm going to give you an overview of today's sessions, and I'm going to set the stage by describing our most common customer need and starting interest regarding infrastructure. Then I'm going to talk about the learning options that are available to help you address it. Coming up, expert Googlers are going to guide you through 2 hands-on labs. They'll start by explaining how to get free access to Quick Labs, our hands-on learning platform, and they're going to show you 2 infrastructure labs: site reliability troubleshooting with cloud monitoring APM, and multiple VPC networks. You'll have an opportunity to ask your technical deep dive questions in those sessions. The last part, I'll explain more about the Professional Cloud Architect certification, and you'll get more information on that later on today. You'll learn about its value to your career and to your organization. You'll learn tips and tricks from certified subject matter experts, and we'll describe how to best start your certification journey. Now let's head on to solving infrastructure problems with Google Cloud. Customers come to us with the need to access cloud infrastructure on demand and scale it cost effectively. They want to know what are the available solutions for rehosting and replatforming application. How does Google Cloud approach infrastructure modernization? That's what this track is all about. The courses in this track are all about implementing, deploying, migrating, and maintaining applications in the cloud, and they offer hands-on experience all along the way. Google Cloud's approach to infrastructure is built on several foundations. First, it makes available a wide range of resources, starting with a variety of virtual machine families, many 2 GPUs, so that you can choose the right family of virtual machine for different workloads. Google Compute Engine provides virtual machines that are easy to provision, to reconfigure, and to scale up or down. Google Cloud also provides Kubernetes in a managed environment, Google Kubernetes Engine, the easiest place to run Kubernetes. Google Cloud's infrastructure is flexible. You can independently configure CPU and memory resources of Compute Engine virtual machines and Kubernetes Engine clusters to find the right balance for your application. Google Cloud was a leader in billing on a per second increment, offering committed savings discounts, automatic discounts, reservations by zone, storage lifecycle management. All of these features help customers control their cloud costs. Google Cloud offers easy to understand options that make it simple to get started, to modify your cloud deployment as your business model changes, and scale your use of the cloud as you grow. Google Cloud's reliability is built on the same infrastructure that Google as a whole relies on. Google has more than 8 products with more than 1 billion average monthly users worldwide. Therefore, Google has made enormous investments in reliability engineering that our Google Cloud customers get to benefit from to make their applications as secure, fast, and reliable as possible. Google Cloud is constantly innovating. As products improve, so do yours. To learn more about Google Cloud infrastructure, here's the learning path we recommend. This diagram illustrates a sequence of on-demand training courses, self-paced labs, and other resources that culminate in a professional cloud architect certification. The journey involves online training, hands-on lab experience, and resources such as a practice examination, an authorized study guide book, and other tools to help you become ready to attempt this challenging exam. We're going to help you get started today. As part of this study jam, we're going to introduce you to the sequence of activities that culminates in a skill badge, which is one of the pathways to a certification. The skill badge on deploying and managing cloud environments in Google Cloud. As part of this activity, my fellow Googlers are going to demonstrate to you 2 of the hands-on labs in the sequence, multiple VPC networks and site reliability troubleshooting. There are 3 other hands-on labs in the quest, and it culminates in a challenge lab where you are challenged to complete a sequence of activities using your own knowledge and skills within a limited amount of time in a sandbox environment. Later on, we'll show you resources that you can use to attempt this for free. There are plenty of opportunities outside of this week to continue your learning journey. You can earn more skill badges, including getting access to free quick labs. Just go to cloud.google.com/training/badges. You can also learn more about our full range of professional certifications. Go to g.co/cloud/get-certified. Stay tuned to start your learning journey.
Welcome! You're watching What's Next? Professional Cloud Architect. My name is Magda, and joining me today is Yuri. We have Googlers on standby to answer them. So let's get started. Welcome to What's Next? Professional Cloud Architect. As mentioned, my name is Magda, based in San Francisco, and I'm the global lead for Google Cloud Certification Go-to-Market. Today with me, joining in the interview and the expert section, will be Yuri, who's also a fellow Googler on the CRE team. We are delighted to introduce the agenda of today's discussion. We'll start with just the overview of the current demand for cloud computing roles. We'll then continue with our learning resources and also the overall overview of Google Cloud certifications. We'll then have this segment of the expert conversation with Yuri and hear some certification success stories. And in the end, we'll wrap up with some benefits as well as ROI. So let's get started with the demand for cloud computing roles. As we all observe, the cloud adoption only continues to grow, and the cloud skills are in high demand. So really people with the skill set to know how to operate and take the best out of cloud and make the best use of it in the organization, there's really a lot of demand for that these days. Specifically, the demand for Google Cloud is growing really fast. So this is the skill that's seeing the fastest growing demand. And when we think about some of the trends behind this situation, we may think about the multi-cloud trend. So our customers do want to have a choice of technologies that they deploy in the organizations. We also believe that Google Cloud specifically is a technological advantage. It's simply fun and interesting and engaging for engineers to learn about technologies like Kubernetes, TensorFlow, and all the other great Google Cloud technologies. So in this new world with growing demand for cloud skill set, the cloud technology in general requires a new approach to learning. And with Google Cloud, we built learning programs that are really transformative. And what we mean by this is you'll notice how our learning programs are really tailored to today's fast-paced environment and world. Our curriculum, our trainings are based on a job role. So rather than going by a very specific technology, we really offer trainings that appeal to a person's real life experience and a real life job. And then secondly, the reason our learning programs are so transformative would be that we really aim to help teams thrive and really enable this shift from maybe historically being more in the maintainer mode, shift into the strategists, innovators, and technology disruptors. So let's take a closer look now at some of the learning resources that Google Cloud offers, as well as our Google Cloud certifications portfolio. So we have several ways to engage in learning, and we do recognize that both various people learn in a different way, and sometimes we just need flexibility of formats. That's why in our learning portfolio, you will find both modalities that are instructor-led. So really, our authorized training partners deliver high quality and current content live or in a virtual classroom. We also have the same curriculum available in the on-demand format, so you can watch it at home or wherever is the really right timing for you to study. Cloud is such a practical skill set. It's really all about having the hands-on experience, and we are really delighted to have the hands-on labs in our learning offering where you can practice with all the Google Cloud technologies. And then lastly, we have our Google Cloud Certified program, which provides this benchmark to measure your team's cloud skills, proficiency, and really providing team leads, employers, confidence that the right skill set is there. And for you as an individual, also the greatest level of achievement in your job role. So our proficiency and role-based certifications give you a benchmark for success. So let's take a look at our Google Cloud certifications portfolio. You'll notice we have professional level exams, Associate Cloud Engineer exam. Our professional level exams, we highly recommend around 3 years of practical experience in the industry, including 1 year of hands-on experience with GCP. And we wanted to show you this map of resources. If you are wondering, where do I start? What are the available resources for me to get started and get ready for the exam? So over here, you'll notice a map of all the learning resources and preparation materials that are available per exam. And if we review this journey specifically for the professional cloud architect that's under this infrastructure modernization path, you'll notice all the core trainings that we have available, the trainings that are available both on demand as well as classroom. You'll notice all the self-paced labs that are highly recommended to get ready for this exam. Additional resources, including our practice exam for this certification or any other, as well as the Professional Cloud Architect Study Guide, and a specific course that's titled Preparing for the Cloud Architect exam. So this study guide that I mentioned is something that we offer for the Professional Cloud Architect exam. You can either purchase this as a book, the hardcover book, or you can purchase this as an ebook, so whichever format suits you better and supports your learning. So that you know that this is another resource that's available for you to support your preparation for the certification. The question we quite regularly hear from candidates is, what is the actual difference between our associate exam and the professional level certificate? So even though there is no prerequisite, so you can go straight in, take your Professional Cloud Architect exam whenever you're ready, there's no prerequisite. Some of you may consider approaching both, so it's good to understand what are some of the core differences. For our associate level exam, it very highly focuses on the technical requirements in the overall customer implementation project. So if your daily job involves building, deploying, that's really the type of knowledge being tested on this exam. The professional level certification also focuses on these technical requirements, and on top of that, it really adds a very significant amount of business requirements and focus. So ensuring reliability. So these are the type of tasks and skills that you could expect that would be tested during the professional level exam. And both of these work streams then contribute to the overall successful customer implementation. And on your team, you need people with both of these skill sets. A little bit more on our Professional Cloud Architect exam. This is in this role, this person enables organizations to leverage Google Cloud technologies. Specifically, this individual can design, develop, and manage robust, secure, scalable, highly available, and dynamic solutions to drive business objectives. Here are some of the more specific domains that all of this can be found on our external certification page, together with a very robust certification guide where you can find a very thorough description of the domains that are tested during the exam. So Professional Cloud Architect exam assesses your ability to, for example, design and plan a cloud solution architecture, manage and provision the cloud solution infrastructure, design for security and compliance, and so on. Let's talk a little bit more about the format of the exam. The exam is 2 hours long. It is multiple choice and multiple select. There are no prerequisites. However, we strongly recommend the actual hands-on practical experience in order to be successful during the exam. When it comes to the exam delivery method, it can be taken both in person at a testing center as well as remotely via the remote proctored option. For the requirements of the remote proctoring, we highly recommend to review the FAQs beforehand to really satisfy all the requirements. And for both options, both remote as well as in person, we highly recommend to book your exam in advance to make sure that there is availability. So right now, I'm very delighted to have this conversation with our guest, and we'll cover some of the certification success stories. So Yuri, if you could please introduce yourself and let us know a little bit more about your role here at Google.
Sure, and thank you so much for having me today. I really appreciate it. I'm a site reliability engineer on the Google Cloud Reliability, the customer reliability engineering team, rather. You can find some of the work that I publish externally on Medium, on YouTube, and on GitHub. My team is really focused on helping Google Cloud customers design, build, run, operate appropriately reliable applications at scale.
Excellent, thank you. So could you let us know a little bit more about your motivation to take the certification exams?
Looking to build applications and services at scale at Google Cloud, and often having to make somewhat difficult architectural decisions around exactly how to accomplish their business objectives, how to use the technology that we were providing to do what they needed. And I found that I think the kinds of experience that kind of going through the certification process has given me have since proven invaluable to do that. So I think my primary motivation was really to able to help the customers that I was working with to make complicated architectural decisions, to kind of understand trade-offs that between various services or various approaches, and to also understand how things like reliability and security play into those decisions as well.
Great, thank you for sharing. So how much time did it take you to prepare? How would you recommend to others? How much time should they plan to prepare for the exam?
Yeah, that's a great question. I believe for me, it was a matter of a few months, I think 3 to 4 months, although as you can imagine, it wasn't spent entirely on exam preparation. I was kind of doing it as I was also ramping up in my day-to-day responsibilities as well. But I would say that for someone who's kind of coming into it from the same place that I was, which is relatively little cloud and GCP knowledge, I would say that plan to spend maybe a couple of months of preparation. Again, assuming that this is something that you'll be doing as you're also juggling all the other responsibilities that you have.
That's right, thank you. And in this process, what would be some of the most useful preparation materials that you found?
Yeah, another great question. So the thing that I found the most useful was really the combination of Coursera and Quick Labs. I went through the Coursera course on architecting applications. I believe it's called Architecting Applications in Google Cloud. And I really found that it definitely put me in a position to be successful when I went in for the exam. I think it kind of sets up the problems, really walks you through all the different products and solutions that are available, so you can really start to understand how they all fit together, how to make decisions between them, what the trade-offs between them might be, how to also consider things like reliability and security and operability as you make some of these decisions, how to start considering things like scale and growth into your decisions as well. So I really can't recommend the Coursera class highly enough.
Excellent. So sounds like this combination of the on-demand training as well as the hands-on experience with labs.
Yeah, absolutely. Quick Labs, I think, is a great resource that really kind of gives you that that hands-on experience. It gives you a way to actually, kind of better understand how these products work, how you can go about connecting the two. Some of the details obviously are hard to communicate in an online class like Coursera, and I think those are the gaps that Quick Labs does a great job of filling in.
Thank you. So what would be your top tips for successfully passing the certification exam?
I would say that the biggest thing that I would advise folks, obviously after the preparation, right? Once you're actually at a point where you've signed up for the exam and you're taking it, and I think this is especially rings true for folks that may find themselves, challenged by standardized tests or tests of any sort, where it can be a kind of a stressful situation. I think the biggest thing I would recommend is, have a strategy for managing the pressure and the stress when you go into the exam. I think the thing that helped me was to really keep in mind that the amount of time you have to complete the test is actually quite generous in my experience. The test is entirely multiple choice, so I think that can place some additional stress, because then you sort of, at every question you're faced with a selection of answers, and some of which look intentionally quite similar to each other. So it's really important to be able to very carefully read the question, really understand what the question is getting at, read through all the different options that you're presented with to answer the question, really understand the distinctions and differences between them, because there could be subtle things that, could make one question significantly more correct than another. And I think it's difficult to do that kind of careful reading and careful parsing of the information if you're all at the same time trying to kind of manage your own stress, managing your own nerves. So I would strongly recommend you really thinking about, what is it that you need in order to be able to stay calm during the test, really focus on the task at hand, while remembering that you're really not under significant time pressure, or at least you shouldn't be. You have enough time to do all of that, and then to go back through and revisit the questions that you had doubts on, which for me was a non-trivial amount of them. And still come out of it, I think, feeling like you're able to give it your best shot and put in your best effort, and in the end, I think you'll be successful. But I think, if I were to advise someone, with really one thing, I would say, think about how you're going to manage the test situation itself, and what do you need to do to remain calm during it.
So Yuri, what was the most rewarding outcome of preparing and achieving the certification?
Yeah, that's another good question. So I would say, I think what I got out of it was really exactly what I went in looking for, which is, how can I be better equipped to work with the customers that I work with, to help them understand some of the architectural, security, compliance, and reliability challenges that go into making these decisions as they start to build applications at scale. So the most rewarding part for me was the fact that I think I did feel much better equipped after going through the preparation and the test itself, in order to get the certification. But it's actually the training and the preparation, what I think was really the rewarding part. I know it's maybe a bit cliche to say, but I think the knowledge and the experience and exposure that I got to the platform as a result of going through the training were, I think, absolutely the most rewarding part for me.
That's great to hear. And so in addition to the Professional Cloud Architect certification, have you approached any other exams?
Yeah, I actually have. So the Professional Architect one was my first certification. I went on to get the Professional Data Engineer one after that. Since then, I've gotten the Professional Developer and the DevOps Engineer one. That was the last one I got.
Congratulations. That's a great achievement.
Thank you. I really feel like they've all been, I think, very very relevant. I feel like from going through the preparation for each of those in my role. So yeah, I absolutely highly recommend the certification.
Great. And anything else, Yuri, you'd like to leave our audience with today?
No. Well, sorry, not no. I guess two things. One, you should do this. I think it's absolutely worth your effort. And you can do this. You can absolutely be successful as long as you are willing to do the prep work.
Thank you. And we are here to support you, share all we can to help your journey. And thank you, Yuri, also for sharing your insights about how the overall process of gaining knowledge, new skill set, that it does take time in our daily routine. Definitely, this is an additional work that needs to happen. So planning accordingly sounds like is really a key to success as well.
Absolutely. And thank you so much for having me. I really appreciate it.
Thank you. Thank you so much. So we will proceed to our last section today, the benefits of certifications and the ROI. And let's briefly cover some of the recent studies about the benefits according to IT decision makers. And it's based on a survey from Global Knowledge. So interesting data point is, to start with, that for the IT decision makers who authorized training in the past 12 months, pretty much 2/3 did so to prepare their team members for certification or recertification. When it comes to the certification value, 93% of IT decision makers agree that certified employees provide added value above and beyond the cost of certification. And then 63% of the IT decision makers say the economic benefit of certified employees exceeds $10,000 a year. You can find more really interesting, useful data information in the link that we provide. Some other benefits, more on the individual level: distinguish yourself with a Google Cloud Certified badge and certificate, something you can share in your social networks, add to your email signature, and so on. For our professional level exams, you can receive exclusive Google Cloud Certified swag. You have access to the network and the community of certified individuals worldwide. And then at selected event, you will also receive some special recognition. So something we would like to leave you with is hopefully this desire and just knowledge that you can do it, you can prepare, and we wanted to equip you with some information about useful resources to now go and practice. So we'll take a quick look at the Quick Labs demo, which is the platform for the hands-on labs. So let's take a look at this short video to get you started with Quick Labs.
Want to start learning how to use Google Cloud using the real thing at little or no cost? Let me show you how using Quick Labs. Quick Labs is an online interactive learning environment where you can get practical hands-on experience with Google Cloud without having to sign up for a GCP account, but still access the full real Google Cloud platform at no additional cost. You'll learn using live real-world scenario-based use cases on the real Google Cloud platform, not a demo or simulation. Start with the essentials, or get deep into specific subjects in over 400 labs, like machine learning, security, Kubernetes, app development, or building your own chatbot. Make learning fun by earning badges or competing in lab challenges to show off your accomplishments. Visit google.quicklabs.com to get started.
So, are you ready to start your certification journey? We have a special campaign for you. Go to g.co/cloud/certify to select the certification you want to work towards. We will email you a 6-week study plan and free training resources to help you get ready for certification. You can schedule to take your certification exam when a testing center near you is available, or you can take it online from the convenience of your own home. We have another special offer for you. This is an exclusive offer for 50% discount of the Associate Cloud Engineer, Professional Cloud Architect, and Professional Data Engineer study guides. please make sure to visit our resource tab for the discount code and more information. We really hope that you continue to join us for our weekly sessions to expand your expertise with engaging learning sessions, hands-on labs, and live technical sessions with our Google Cloud Developer Relations team. So please register now for free on g.co/cloudnext. Thank you so much for tuning in. Please visit cloudonair.withgoogle.com for more hands-on learning, training, and demos from Google Cloud experts. I want to thank Yuri for joining us today. Thank you, Yuri, for sharing your expertise. And thank you all for joining.
Webinars from Google Cloud. My name is Rich Rose, and you're watching hands-on lab sessions for our infrastructure-focused Cloud Study Jam this week. Coming up, we have a few slides on Kubernetes, and following right after, we have a lab walkthrough using Quick Labs. You can ask questions at any time by submitting them in the box below this screen, and we have Googlers on standby to answer them. Okay, let's get started. As I said, my name is Richard Rose. I'm a training curriculum lab architect. And this section is going to be about orchestrating Kubernetes. So in this section, we're going to be talking about three things. We're going to be looking at what is Kubernetes orchestration. We're going to be looking at doing a hands-on lab to walk through that process. And then finally, we're going to have a demonstration of orchestrating the cloud with Kubernetes. So in terms of Kubernetes orchestration, there are a couple of things that are relevant to pull out. So on the left-hand side of the slide, you can see that Kubernetes provides a number of things. So you have things like service discovery, storage orchestration, self-healing, and configuration management. Now, the orchestration part of that on the right-hand side is really talking about is able to manage each of those things automatically for you. So on a typical system outside of Kubernetes, you may need to do some manual type activities associated with that. The power of Kubernetes is when you're using that, it will automatically provide you with those services out of the box. So in this slide, we're really talking about using labs and getting an understanding of particular technologies. So with Quick Labs, Google Cloud's hands-on learning platform, you can experience a sandbox environment with real Google Cloud resources, and that's quite powerful. There are a couple of ways you can get access to the lab that we'll be demoing today. So first of all, you need to make sure that you have an account and you're able to sign into that account in order to be able to use the element and the environment that's been provided for you. If you need to take a second to create an account to get started, don't worry, you can pause this and watch it later on demand. And if you want to just focus on watching my lab demo and asking questions in the Q&A below, don't feel that you need to log into Quick Labs right now. You can follow along with these instructions to access the labs after the session as well. If you're following along live with us this week, as part of the first week of Google Cloud Next on Air, you can hop into this week's Cloud Hero game, a week-long challenge of created labs relevant to this week's theme. The lab we're going to go through today will include this week's challenge. You don't have to do all the labs in the game. Each lab in the game can be tied up to 5 times, and there will be a prize in the game for the top 10 winners. The link goes to the Quick Labs landing page listed below, and rules included in terms of joining, scoring, etc. If you need to take a second, don't worry, you can pause and watch this video later. You can get access to all these labs, and you will want to focus on watching me instead, asking questions in the Q&A, and you might also feel like you'll need to know how to log into Quick Labs as well. So get ready to do that and you'll be all good. Okay, so the link to the actual game is provided. The URL that you need to access the Cloud Hero landing page, you'll find this in the links. This will give you access to the weekly challenges and the game access. Just to let you know that in order to play the game itself, you'll need a URL and you'll also need an access code. These will be provided to you. In terms of the games that are presented, the games have a collection of relevant labs that are in a particular space. So for this week, we're looking at infrastructure. So feel free to go through the agenda, find one that's relevant to you, and then take it from there. Okay, now's time for the lab demo. Good luck. So the first thing we need to do is enter the credentials for the lab. So here I'm entering the username allocated by Quick Labs. Next, it will ask me for a password. So I use the Quick Labs console to supply that password. And then accept the terms for the new account that's been provisioned. Then confirm. And then we'll start to see our account being provisioned for the first time. So here we go. Okay, so we just need to agree the terms of service. So let's agree that. Excellent. So we're into the project now. So going back to the instructions of the lab, let's just take a look at what we actually need to do. So the first section talks about Google Kubernetes engine. So it looks like we need a Cloud Shell environment. So to open a Cloud Shell environment, go straight up to the top right hand corner to activate Cloud Shell. click on that. And what we're going to do is make a Cloud Shell environment. But in this instance, what I'm going to do is open this in a new window. So if you click on this icon here, that will create a Cloud Shell that we can use. So we'll basically have a Cloud Shell at the bottom of the screen, and we'll also have a Cloud Shell in this tab. So what I'm going to do is just get rid of this Cloud Shell, so make it easier to see. And also let's make this text a bit bigger so we can actually see the commands. So the majority of the commands that you need are actually located in the lab itself. So what we're going to do is start off by creating a zone setting for the lab. So here we're just saying, make sure that my project relates to US Central 1B. Okay, so that's updated. The next thing we need to do is create a Kubernetes cluster. So we do that. So creating a cluster takes a fair bit of time. So normally a couple that are situated in US Central 1B. The machine type is going to be an N1 standard 1, and it's going to have 3 nodes dedicated to it. The name of the cluster is going to be IO, and once it's finished, we'll be able to see it both in terms of the Cloud Shell environment that we have open here, and also in the Google Cloud console as well. So if we switch back to the console, what's actually happening is we're actually creating a number of VM instances in the background. So if we go to VM, you can see here that we have 3 VM machines created, all in that zone, so US Central 1B, and all in use by GKE. And similar, if we go into the Kubernetes engine menu option, you can see that we have a cluster by the name of IO being created of the size 3 with the relevant memory and cores associated with it. Also quite handy in terms of the provisioning of the cluster is that Google will tell you the time it's taking in terms of the percentage. So at the moment it's doing the health checks and making sure that they're available for the cluster. And once that's done, then we're ready to rock and roll in terms of Kubernetes. So if we switch back to Cloud Shell, you can see that that's nearly finished. So we can see the next stage of the lab, which is to get some sample code. And this is sample code that we're going to be running throughout the rest of the lab. Okay, so there we go. Our cluster's created. You can see the relevant details in terms of the cluster. So the master version that's been used, the master IP, the machine type, the node versions, number of nodes, and the status of the cluster as well. So next in the lab, we need to clone some code. So let's just add that in. It's a quick operation, cloning that code. Next thing it asks us to do is to change directory to orchestrate with Kubernetes. So we do that. And then if we look in this directory, we can see the files that are available to us. So that's pretty cool. So the next thing is really just a quick introduction to Kubernetes in terms of the demo. So the lab asks us to create a deployment. So let's do that. So we can see that that's done relatively quickly. So the next thing we want to do is just to check what's actually been deployed in terms of Kubernetes. So if we run kubectl get pods, that shows us that we have successfully deployed the image. So the image that we wanted was Nginx, and that image is now ready and operational. It has a status of running. It has 0 restarts, and it's been alive for 17 seconds. So that's pretty cool, but we want to be able to talk to that deployment. So the way we do that is we're going to introduce a load balancer to our environment and expose port 80. So we hit that. Kubernetes will come back and say you now have a service for Nginx, and it's been exposed on the port that you specified. So the port that we specified was port 80. So that's now available to us. So the first thing we should do is just check on that service that we've just created. So we can see that Nginx has been deployed as a load balancer with a cluster IP. However, the external IP associated with that service has not been made available as yet. It's in a pending state. So let's just check on that. So now we've double checked on that. We can see that we now have an external address of 35.224.143.3. Okay, so in order to test that, what we can do is we can just run a curl command against that particular address. So in the lab exercise, it asks us to replace the address, so with an external address. So the external IP associated with Nginx is the 35.224.143.3. Okay, and then we add to that port 80. Message back saying welcome to Nginx. Similar, if we were to take that address, if we were to take that address and just copy it and just go to a new tab and type in http / and then the IP, we get the same thing. So we get that web page, it's now available to us, and it's accessible from Kubernetes. So that's a quick introduction to Kubernetes. So in the lab interface, we can see we've got a checkpoint here. So let's just validate our lab. Yep, we get a green tick, which means we're on track. So the next part is talking about pods. So pods are basically a representation and hold information about containers. So generally, what you're trying to do is have one or more containers deployed to a pod. And pods can also use volumes. You can have different namespaces associated with them. And you'll have an IP per pod allocated as well. So in the lab, what we're going to do is we're just going to work through a quick use case of pods and show how they're used within the Kubernetes environment. So the first thing it asks us to do, and let's just clear this screen to give us a bit more real estate, is just let's have a look at our configuration file. So with Kubernetes, what you'll see is typically your configuration files are expressed as YAML. So in this one, we're seeing a pod generated that will be called monolith. And it will have various settings in terms of arguments added to it. So you can see in the middle, you've got HTTP, health check, and a secret configuration file on Kubernetes. So what we need to do is just run this command. So kubectl create -f and then pods/monolith.yaml. So it's going to run this file and tell Kubernetes to get that created. So we do that, and there it comes back. So the next thing we need to do is we need to check on the state of that pod. So how we do that is with kubectl get pods. So we tell Kubernetes, can you tell me some information about the pod that I have just deployed? So there you can see at the top, the monolith has been deployed. It's got one pod and it's ready for action, and its status is running, and it's been there for about 15 seconds. So that's cool, but you may want to know a bit more about the actual pod that you've deployed. So in order to do that, you can basically use the describe command. So far we've used create and get, but we can actually describe the resources that we deploy. So the describe command gives you a lot more information about the resource deployed. And here we can see pretty much everything we want to see in terms of the IP address, the event logs, the conditions, the volumes, a bit more about the container and the requests associated with it, the IP of that resource as well. So that's a quick overview of pods. So the next thing in the lab is talking about interacting with pods. So here we're going to crank up the level slightly. So the first thing it asks us to do is open another terminal to run a command. So what I'm going to do is at this stage, I'm just going to use tmux. So if you're not familiar with tmux, it basically allows you to use multiple windows at the same time. And handily, Cloud Shell has tmux installed by default. So if I just open another window here. Oops. Okay. So the first thing it asks us to do is port forward for the monolith. Okay. So on the right hand side of the screen, basically we've started to forward communication from the local host on port 10,080. And that will redirect to port 80. So remember, our monolith is actually running on port 80, so we'll need to intercept traffic to send it to that. So in the other window, please skip back to there, and actually let's just reconfigure this so that we have the right configuration better. In our other window, what we can do next is it tells us to initiate a curl command to that endpoint that we've created. So here we're going to talk to the local host on port 10,080. And what that should do is in the bottom half of the screen, you should see some information. So there you go. So in the top half of the screen, the response back from that curl command is some JSON to say we have a message, and that message is hello. In the bottom half of the screen, we've got the information being captured as it's coming through. So we can see that a connection has been granted, and that connection is coming from port 10,080. So the next thing it asks us to do is talk to another endpoint. So this time, this endpoint is /secure. So this sounds interesting. So let's see what this does. Oh, so this time, this comes back with authorization failed. So in the bottom half of the screen, again, you still see that connection. So the information is still getting through to that pod that's running. But this time, because it's going to the secure endpoint, it's coming back and saying, yeah, I don't know who you are. So let's try and fix that, I guess, in the next section. So we've got that secure. So next it tells us to try logging in. Okay, so let's try that. So this time, again, the URL changes. So this time we've got, instead of secure, we've got /login. So if we try this, this time it's asking us for a password. Okay, so it says that the super secret password is actually password. Okay, so let's try that. Oh, okay. And having entered the password correctly, we get back a token. So it's saying that as a next step, we should add that token to an environment variable, which seems legit. So let's try that. Okay. So in this command, basically all we're doing is the same command again, but this time, once it returns its payload, we then take out the token element and assign that to an environment variable. So let's try that again. Password. Okay. So now if we check that token, yay, awesome. Okay. So the token has been captured successfully into the environment variable. Okay, so the next thing it asks us to do is try and talk to that secure endpoint again, but this time pass it the token that we just saved into an environment variable. So one of the things to note here is that you can actually pass a header with some credentials to an endpoint. So this is an example of that. Okay, so that's cool. So now we've got the authentication token. We can actually pass that to the secure endpoint, and that comes back with the JSON payload of the message and hello. So that's pretty cool. Okay, so the next thing it asks us to do is, at this point, you'll get the message back. So you'll want to look at the logs to make sure that this is working as expected. Okay, so if we just get this line here. Okay, we can see lots and lots of data and all of those requests coming through from us. So that's pretty cool. So the next thing it asks us to do is we need another one, which is good. Okay. I think I've got a slight keyboard failure here. Okay. So the next thing it asks us to do is to make a stream of the logs so we can access all of that good stuff. So if we do that, okay, so that's pretty cool. Okay, so let's recap what's happening here because we've got lots of information going on. So in the right-hand corner, top right-hand corner, we've got a cap of the logs coming back from our access to the monolith. In the bottom half of the corner, and let's just make this slightly bigger, we've got the connections being forwarded to our monolith. And then finally, let's make you just a bit smaller because you're not that important. Okay. And then finally, on the left-hand side, we have the ability to push commands to our pod. So that's pretty awesome. So the next thing it asks us to do is run another curl command. Okay, so let's run that curl command. Okay, so we're still getting that, and we can see each time we issue a curl command, we can see that generates a connection request at the bottom, and also we get the logs on the right hand side as well. So the next thing it asks us to do is we want to try and access that container. Okay. So what we've done here is we've logged in to that container that's running, the monolith, and we're going to execute some commands from inside that container. So what it asks us to do is to do a ping with a count of 3 to google.com. Again, that seems fine. Okay, so that's pretty cool. And then once we've done that, we can actually exit from that. We can still see that that's running, which is cool. Okay. Okay, so the next part of that is to understand what that gives us. So the next part talks about different types of services that you can see. So far we've used a load balancer on our cluster. You might have also noticed in the initial part that we've had, or you'll be able to see a cluster IP as well. So this is the default type of balancer that's applied to Kubernetes. The load balancer gives you the ability to forward traffic to particular nodes for the services that you'll see. And there's also a node port which you can use as well. And that gives you an externally accessible IP. So the next part looks at what actually can we do with a service. So let's see what it asks us to do. So the next part asks us to move to a new directory, okay, called Kubernetes, okay, and then we're going to have a look at some code. So let's just wipe that out, and let's have a look. So here we've got a long tail of stuff, so let's just have a look at this in a bit more detail. So in this one we are basically applying a new pod with the name of Secure Monolith, okay, and it's going to have a label of app and monolith. So labels are basically key value pair. So the key is going to be app, and the name pair is going to be monolith. Looks like it's using Nginx as well, again. And that's about as much relevant information as I can see at the top. Oh, and at the bottom, it looks like it's using certificates, TLS certificates. So I guess this is going to be using HTTPS. Okay, so let's continue on. So we need to issue a couple of commands. based on that. So let's just do that and that. Okay, so it looks like we have basically created a secret, then created a config map, and then deployed a new pod. Okay, so that's cool. And then the next part is we need to look at, so let's just make that at the top. Let's look at the service that's going to be used. So remember that the pod deployment is basically sitting there waiting, doing its stuff, but to interact with it externally, you basically need to deploy a service. So this service is going to allow things outside of the node to interact with our pod. So in this respect, in our service, we've said we've got a monolith service. It's going to have a selector of both monolith and enabled. And it's also going to be working on TCP 443. So that's basically HTTPS. I guess that's hence the name secure. And it's going to have a target point or target port of 443. Okay, so that seems highly exciting. So let's just see what that actually does. So we need to get that created. So let's do that now. Okay, that was pretty quick. So that's been created. So yeah, that in the lab, there's confirmation of that. So the highlights in there are that we've applied labels of app equals monolith and secure equals enabled. And we've also looked to expose a node port because that's how we're going to forward the external traffic from 31,000 to Nginx, which is running port 443, HTTPS. So we've done those two commands. That's created fine. So we've got another checkpoint. So we just check we are progressing. Yep, we've got a green tick. So that's good. We progress onto that. Okay. So now the lab is telling me that we are exposing the service and it's using a particular port. So in this instance, 31,000. So normally Kubernetes would handle the port assignment, but in this lab, we've chosen to use another port so that it's easier to configure health checks later on. So what we need to do is we need to add a firewall rule for the monolith node port and allow it on TCP 31,000. Okay, so in order to do that, we can just use the gcloud compute firewall rules create command and do that. So that's going to do its stuff. So it's come back and said, I've created a new rule, which is allow monolith node port, and that's sitting on the default network, and it's an ingress rule. It's got a priority of 1,000, and its intention is to allow TCP 31,000 on there. Okay, so that seems fine. Another checkpoint. So check that we have allowed the traffic to the monolith. So let's just click that. Yep, that's fine. We got a green tick. So let's go on to the next part, which is we need to look at the external IPs. So let's have a look. Oops, cancel that. Oh, I don't think I copied that correctly. So let me just try that again. Yeah, There we go. So the G-Cloud Compute Instances list provides you with a list of the external IPs, and this list is essentially the nodes that we've got allocated within our Kubernetes cluster. So we've got 3 nodes allocated to us, 3 times external IPs. So that's what we're going to use. And then it says we should try hitting the secure monolith service using the curl command. Okay, so we need to pick one of these external IPs. So that's okay. And notice this time on our curl command, we're using HTTPS rather than HTTP. So let's just pick the first one, which is 3471.115.123. And we want that on port 31,000. Okay. Okay. Fail to connect on that IP address on port 31,000. Okay. So that's refused. So let's just read the instructions. So in the lab it says that did not work. What has gone wrong? Okay. So it gives us a quick overview of what's happening and asks 3 questions. So the first question is, why were you unable to get a response from the monolith service? The second question is, how many endpoints the monolith service have? And the third question is, what labels must a pod have to be picked up by the monolith service? So I think the major clue is probably in the last question, talking about labels. So my assumption here is that they have a label for an app and a label for secure. So it feels like we need to add some labels in order to have that be corrected. So let's just progress and see if that bears fruit later on in the lab exercise. So the next lab section is about, surprise, surprise, I think we're on the right track, adding labels to pods. So let's see what we need to do. So it says we've got a few pods running, so let's just list what's available. So let's list this. So in this command, we're basically saying, of the pods you've got running, show me the ones with the label app equals monolith. So we hit that, and we can see we've got basically 2 pods deployed. So we've got one called monolith, which is running 1 of 1, and we've got one called secure monolith, which is running 2 of 2. So that seems okay. So the next thing it wants us to do is check which are labeled secure. So we're running effectively the same command again, but this time we've added secure equals enabled. So we should hopefully see that the secure monolith is in that list. So no resources are found in the default namespace. So that's a major clue. So that is basically saying that we should have something in that namespace for secure equals enabled. So putting 1 and 1 together and hopefully getting 2, I think it's just that we've not labeled the secure monolith at this point in time. So let's read the next set of instructions. So it talks about there are no resources printed. So we need to, as a next step, add the label secure equals enabled. Okay, so let's try and do that. So we take that and we do that. Okay. Excellent. So in the first command, what we're doing there is we're looking for a pod called secure monolith, and then to that we're going to add a label with the key pair value of secure equals enabled. And then in the second one, we're going to rerun our command to show the labels associated with a pod. So in this instance, the secure monolith pod, what labels do you have? And you can see there, it's at the end, it's labeled app equals monolith, and it's also got a label secure equals enabled. Okay, so that seems pretty cool. So the next bit is to describe, I think. So if we do a describe, and let's just make this a bit bigger because all of these colors are quite awesome. Right, so we can see kubectl describe services monolith. Okay, and then we're going to look for the endpoints associated with the monolith. Okay, so the endpoint we can see there, which is cool, and we have one, so that's good. But then we need to test it out. So what we're going to do is we're going to split this next command in the lab because we can. And let's have a look at the compute instances. Oops. Gcloud, what is it? Compute instances list. Instances list. So that should show us the information that we had before. And then what we're now going to do is rerun that command again with the endpoint. So we do the curl k and then https once more. And then we'll take the, I think we used the first IP address last time, so let's use that again, just to be scientific. And then we want 1000. Oh, sweet. Okay, so now we're getting our message back again. So now we're enabled our environment to talk to that pod over port 31,000. So that's pretty cool. And we also have another checkpoint. So let's check that we've correctly added our labels to the pods. And we get a tick. So we must have done. Okay, good. So the next part of this is talking about deploying applications with Kubernetes. The main point here is that Kubernetes, what you're looking to do is always have Kubernetes work with your desired state. So you basically tell it, hey, I want you to have 3 pods running, and it will then go away and deliver 3 pods. You can then specify, actually I want 2 of the pods running on a particular node, or you can say, hey, I want this particular pod to run on a node with GPU capability. You can do lots of interesting and weird and wonderful things with Kubernetes. The key message here is that you're basically looking to define a desired state. So what you're trying to indicate to Kubernetes is, how do I want my environment to run? And then you just let Kubernetes handle the rest. So all the scheduling, all the general orchestration of your pods, where do they need to go in terms of what's the most appropriate home for them. So there's a quick example in here of a node being out of action. So you've basically got a situation where you've got 3 nodes. Node 3 is brought down for some reason. In that instance where you have 3 nodes and the pods have a replica of 3 and they're evenly distributed across your nodes, if your 3rd node is taken down, Kubernetes will say, your desired state is I want 3 pods running. Unfortunately, I only have 2 nodes. So what I'm going to do is I'm going to move one of your pods across to the other 2 remaining nodes. And it will always try to hit your desired state as well as it is enabled. And that's one of the niceties of Kubernetes. So the next part of the lab is really trying to demonstrate deployments. So if we go to this section, what it says is we have looked at the monolith application, and what we want to do in this stage is to basically break it down into microservices effectively. So our monolith is going to be split into 3 separate pieces. We're going to have an auth microservice, we're going to have a hello microservice, and we're going to have a front-end microservice. So the auth piece is basically going to generate tokens for authenticated users. The hello piece is going to provide that greeting for authenticated users. And the front end is basically going to work around routing traffic to the auth and hello services. So our starting point for this is to look at the auth YAML. So let's clear this again, get rid of that, and let's see that. Ooh, big YAML. Okay, so let's have a look in a bit more detail. Okay, so typical name, going to have one replica. It's going to be talking on port 80, and it's not really doing much that's exciting. So yeah, that seems good. So in the instructions, it says the deployment is creating one replica, and we're also using version 2 of the auth container as well. So similar to last time, what we're going to do is use the kube create command. So there it is in all its glory. So we run that again. That deployment is then created. It then says it's time to create a service for your auth deployment. So let's do that. Let's do that. So create that. Good, that's created. Now we need to do the same thing and create and expose the hello deployment. So one thing you'll recognize in working with Kubernetes is there is a lot of YAML associated with it. Being able to just quickly scan YAML is a handy skill to have. Primarily, what you'll find is there'll be lots and lots of instances where the YAML will be effectively the same from process to process that you want to deploy. So being familiar with it to a certain extent is a helpful skill. So in the next step, we are going to deploy the hello part of this. So let's just take a shortcut for this. Take that, and then we are going to, oops, hopefully if I click on the right window, do that, deploy that, and then, so the first part is a deployment, and the second part is a service. So we've done that, and then we get to a configuration piece. So the front end, it looks like, has a config map associated with it. So a config map, if you're not familiar with that term, is basically just a dictionary of stuff. So if you want to label things, you can have a config map created. So it's typically used for things like database names and passwords and things. So if you have a password associated with a particular resource, you can create a config map. It will look up a name, so you give it database X. In the config map, you'll have an entry for database X, and then you'll be able to associate a value with the name or key, in fact, of database X. So you have a key, database X, and a value associated with that. So the value could be a password or a name or what have you. It's just a nice and easy way of being able to have lookup values Let's just take that and implement that. So we create that comp, and then we go through the same steps as we have previously for the auth and the hello. So we then do a deployment first for the front end, and then we do a service for the front end. So one of the things to mention here is that you'll notice the order in which I'm deploying the resources. So I'm basically starting from the lowest level in terms of I need a resource, a pod available. So I look at doing a deployment first, and then once I've got that deployment up and running, at that point then I start to look at the ingress part. So what service do I need in order to disseminate the communication from external of the Google cluster to the pods? That's a good approach to take. It means that you can basically incrementally test each element or each resource that's deployed, and not get into a circular situation when you're trying to work out why a part of your Kubernetes cluster is not working. But it's like with anything, try and build the foundations correctly so that you make your life easier in terms of debugging things. Okay, so that front end is deployed. Okay, so now we have that. Then it says there is one more step to creating the front end. You need to store some configuration data with the container. Okay, so I guess that configuration data is the information that we added to the config map. So the next thing we should be able to do is we should be able to grab the front end service IP. So let's try that. ctl get services front end. Okay, so we can see for the front end we've got an IP address, an external IP address associated with it, and it's been active for 58 seconds, and it's working on port 443, which is cool. So let's just try and access that. So again, we're using HTTPS. We're going to go to 35.1.8, 1.44, and 73. Okay, and we don't need the port because it's on 443 and it's HTTPS. So we do that. And hopefully, if I've done it correctly, not responding. Okay, let's just have a look. Blah blah. That looks legit. Okay, that looks okay. Let's just hello looks hinky. La 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 la. Okay, that's not great. Okay, there you go. Okay, so it's just taking a bit of time to get to where it needed to be. That's all good because we could have panicked, but we stayed strong, so that's good. So that looks like that's working as anticipated. So if we, I guess, go to that IP, it would see something, right? Let's just, let's just have a nosy, shall we? Oops. No, I don't want that. I just want that bit. So, that's interesting. Proceed. Aha. Okay. So we can see that it comes back and we've made that externally available as well. So the traffic going in by that external IP that's allocated goes through Kubernetes, hits that that pod on the secure side using the TLS certificates, which is very easy for me to say, accesses it, and then gives you that response in terms of that JSON payload, so the message and the hello coming back. Okay, so I think the final thing for us to do in this lab is to see if we've checked all the points. Excellent. Okay, so the final part of that is to test the completed task. So the final task is of creating a deployment, splitting out that monolith into microservices. So you have the auth, the hello, and the front end. That looks like everything's worked as specified. So with that, thank you for taking the time to go through this demo with me. There'll be more glorious adventures in terms of both Google Next and further adventures in terms of labs being shown over the course of the coming weeks as well. So please do join us for those. My name is Rich Rose, Lab Architect at Google Cloud. Thanks very much for your time today. That was a lab demo. Hope you enjoyed it. Get a lot out of that in terms of Kubernetes. This next slide is talking about the skills badge quests that have been recently launched. These are to assess your skills in a particular point of knowledge area for Google Cloud. As you can see, there's a link there to learn more about the skills badges. Please do feel free to access that information when you're able. Finally, I'd like to thank you for attending today's session. Thank you for attending Google Cloud Next. I hope you've enjoyed these sessions as they've been presented and got a lot out of them at Google Cloud Next. Thanks very much.
Welcome to Cloud on Air live webinars from Google Cloud. My name is Philip Meyer, and you're watching a hands-on lab session for our infrastructure-focused Cloud Study Jam this week. Coming up, we have a few slides on VPC networks, and following right after, a lab walkthrough using Quick Labs. You can ask questions at any time by submitting them in the box below the screen. We have Googlers on standby to answer them. Let's get started. Again, my name is Philip Meyer, and I'm a Curriculum Development Manager at Google. I'm the author and owner of several infrastructure courses, including the Networking in Google Cloud course. In this session, I will start by providing you with a high-level overview of what a VPC network is. Next, I will show you how to access this session's hands-on lab, multiple VPC networks, which I will demo for you. Let's start by talking about what a VPC network is. This map represents Google Cloud. On a high level, Google Cloud consists of regions, which are the larger circles on the slide, the points of presence or POPs, which are the small dots, a global private network, which are the blue lines, and services. Google Cloud uses a software-defined network that is built on top of this global fiber infrastructure. This infrastructure makes Google Cloud one of the world's largest and fastest networks. A VPC network lets you manage networking functionality for your Google courses. These networks do not have IP ranges, but are simply a construct of all of the individual IP addresses and services within that network. Google Cloud's networks are global, spanning all available regions across the world, as you can see on this map. So you can have a network that literally exists anywhere in the world, Asia, Europe, Americas, all simultaneously. Here's an example of a Google Cloud project that contains 5 networks. All of these networks span multiple regions across the world, as you can see on the right-hand side. Each network contains separate virtual machines, A, B, C, and D. Now, because VMs A and B are in the same network, namely network 1, they can communicate over internal IP addresses, even though they are in different regions. One is in US East 1, which is in South Carolina, and the other is in Europe West 1, which is in Belgium. Essentially, your virtual machines, even if they exist in different locations across the world, take advantage of Google's global fiber infrastructure that I just showed you. Those virtual machines appear as though they're sitting in the same rack when it comes to a network configuration protocol. VMs C and D, however, are not in the same network. Therefore, by default, these VMs must communicate over external IP addresses, even though they are in the same region. The traffic between VMs C and D isn't actually touching the internet, but is going through the Google Edge routers, which has different billing and security ramifications. Because VM instances within a VPC network can communicate privately on a global scale, a single virtual private network, or VPN, can securely connect your on-premises network to your Google Cloud network, as you can see on the slide. Even though the 2 VM instances are in separate regions, that is US West 1 and US East 1, they leverage Google's private network to communicate between each other and to on-premises network through a VPN gateway. This reduces cost and network management complexity. Now, VPC networks are by default isolated private networking domains. VM instances within a VPC network can communicate among themselves via internal IP addresses, as long as firewall rules permit the communication. However, no internal IP address communication is allowed between networks unless you set up mechanisms such as VPC peering or VPN. Every instance in a VPC network has a default network interface. You can create additional network interfaces attached to your VMs through network interface controllers, or NICs. Multiple network interfaces enable you to create configurations in which an instance connects directly to several VPC networks. Each of the interfaces must have an internal IP address, and each interface can also have an external IP address. For example, in this diagram, we have 2 VM instances. Each instance has network interfaces connected to a subnet in VPC 1, 2, and 3. Typically, you might require multiple interfaces if you want to configure an instance as a network appliance that does load balancing, intrusion detection and prevention, web application firewall, or WAN optimizations between networks. Multiple network interfaces are also useful when applications running in an instance require traffic separation, such as separation of data plane traffic from management traffic. In this session's hands-on lab, we will create several VPC networks and VM instances and test connectivity across, with, and without multiple network interfaces. Specifically, you create two custom mode networks, Management Net and Private Net, with firewall rules and VM instances as shown in this network diagram. The MyNetwork network, with its firewall rules and the two VM instances, MyNet UVM and MyNet USVM, have already been created in this lab. So let's get on to Quick Labs, Google Cloud's hands-on lab learning platform, where you will be able to access a sandbox environment of the platform. There are a couple of ways you can get access to the lab I will be demoing today. First, make sure you make an account or sign in before getting started. In an incognito/private browser window, go to google.quicklabs.com. Then click Join to create a new account, or Sign in to sign into an existing account. If you need to take a second to create your account/get started, don't worry. You can pause and watch this later on demand. Also, if you want to just focus on watching my lab demo and asking questions in the Q&A below, don't feel like you need to log into Quick Labs right now. You can follow these instructions to get access to the labs after this session as well. If you're following along with us live in week 3 as part of Google Cloud Next on Air 20, you can hop into this week's Cloud Hero game, a week-long challenge of curated labs relevant to this week's theme. The lab we're going through today is included in this week's challenge. You don't have to do all the labs in the game. Each lab in the game can be tried up to 5 times, and there will be prizes for the top 10 winners of the game. The link to the Quick Labs landing page of this game is linked below this video and includes the rules, how to join, and some information on the scoring. In short, the quicker you complete the necessary tasks of the lab, the more points you get. Again, you can pause the video to log in and get started, or you can just watch me go through the lab for now and ask any questions you have in the Q&A. Here's a screenshot of the Cloud Hero landing page that you can access with the URL on the right. On this page, you'll be able to find the links to the weekly challenges and the game access codes. Again, this lab is part of week's 3 game. Once you join week 3 game, you'll see the screen shown on the left. Now, I've already joined the game and I'll open the lab in a second. This game actually has a collection of relevant labs to this week's game, and again, I will go through the multiple VPC networks lab together as a group with you. So let's get into the lab. So here I am on the Cloud Hero game landing page, and as I mentioned, we're going to be doing the multiple VPC networks lab. You can see I've already done that here. You might not have that checkbox, but this is the lab that you want to click on, so I'm going to go do that. And that is going to bring me to the page of the lab itself. Now, small thing I want to point out on the right-hand side here, a bit squished on my screen, you have the leaderboard. So as you're completing the labs, you get points for the different activities that you complete. The faster you do them, the more points you get. And again, you can do the lab up to 5 times. So you can improve on your score. It'll only keep a score. All right. So the lab itself has multiple instructions. I'm actually going to get started. And what that is going to do is going to provision resources for me. It's going to give me an account, a password, and a username. And in the background, it's actually going to provision some Google Cloud resources. You can see that here, it says about a minute remaining for these resources. So let's take a look what this lab is doing for us. So if I scroll down, there is a network diagram here. And in there, you can see that we are going to be creating different instances in this network. But we have to create all these networks. Well, the lab itself is actually going to create the MyNetwork network for us, along with these 2 instances here. And then we're going to go in and create the 2 custom mode networks, Management Net and Private Net, along with firewall rules and VM instances. Once we've done that, we test the network connectivity, and then we create this VM appliance that's over here, and that will have network interfaces in all 3 networks, and then we'll test the connectivity again. So let's take a look. It's still provisioning the lab resources. It'll be ready any moment. And again, what that does is it gives us an account and username so that you don't have to use your own GCP credentials and with that, your own credits or your own credit card that's tied to your account. So we're going to wait for that to pop up, and then we're going to be logging in with those credentials. We'll also have to go through some user signing workflow for the first time. But once we're in, we're ready to go. While this is loading, and another thing I'll mention really fast is, I already said the faster you do it, the more points you get. This lab actually has a couple of steps that are done in the UI, the GCP console, but you can also complete those steps in the Cloud Shell, and I'm going to show you both. If you do it in the Cloud Shell, you're going to be a little bit quicker. So maybe the first time you run it in the UI, and the second time you run everything in the console, in the command line. All right, here we are. So I'm going to copy the username and click on Open Google Console and paste that username in here, and then go back to also grab the password and sign in. And I'm going to make this a little bit bigger here. I'm just going to accept these terms of services. I don't need a recovery account because this is just a test account. It will actually be deleted after this timer that we have here in the lab is over. And I'm switching back to the console. I'm going to come in here, accept the terms of services. And then I'm also going to increase the font a little bit here, just so I can show you things a little bit better. Now, this is the Google Cloud Console. We're going to be using that a lot. And we're also going to use right up here, Cloud Shell, which is the command line, which we can activate. Now, one thing that's always important is to just verify that you're using the right account. So if I click on here, you can see the right account. And if I click on over here, you can see the right project. And this project, if I go back to my Quick Labs tab, is the same project ID that I've been giving here. So the other thing I recommend is take the instructions and put them in a separate window so that you have two windows and can kind of work more quicker. And that's what I've actually done. I have a different window where I have the instructions. So I will be focusing now completely on the console and walk you guys through that. So first thing we want to do is in the navigation menu here on the left-hand side, I'm going to scroll down to VPC networks. Because the first thing we want to do is verify that this network that I talked about was created. And if I collapse the default network, which is created for every project, we can see we have the My Network. It's an Automo network, meaning that we have a subnet for each of the different GCP regions. And that's exactly what we have here. So that's great. So now we're going to go ahead and create our own network. So I'm going to click on Create VPC Network. And we're going to give it the name Management Net. And you want to make sure that you follow the instructions in the lab to the dot points. So I'm going to put in Management Net here as the name. Now here is where I can choose between the subnet mode creation mode, either automatic or custom. We're going to create a custom one, meaning that we're just going to create a subnet with the name from the lab instructions, which is Management Subnet US. It is in the region US Central 1. And we also have an IP address range. So that's it. Now I can click create, but before I do that, I want to show you the command line version of this. So if I click on this little link down here, command line, it pops up another window and it tells me the G-Cloud command line. The first one is to create the network. Let's make this bigger, which has the name of the network, the project, which I don't have to define if I've already set the project in Cloud Shell, the mode, which is a custom network, and then this routing mode is actually optional as well. It just takes the default if I don't define this. Then I define the subnet. So I again create a subnet, give it a name. Project is default. The range is important. The network it's attached to, Management Net, as well as the region. So these are really the three required things along with the name. So let's close that, create this network using the Cloud Console. And now the next network we're going to create using that command line. So for that, while this runs, I can click up here on Activate Cloud Shell. And I'm going to click continue when being asked to continue. And I like to actually open this in another window. And that just gives me a little bit more room so that we can focus a little bit more, increase the font, which I'm going to. And there we go. So the first thing I'm going to do in here is now run that command gcloud compute networks, create the name of the network, and the fact that it is a custom mode network. Now, I need to wait for this network to be created before I can create subnetworks for it. We're actually going to create two subnets. We're going to create one in US Central 1 and another one in Europe West 1. So I'm going to do that, run the commands from the lab, one to create it in US Central 1 with a specific IP range. And then again, I'm going to do the same for our Europe West 1 subnet. So we're just waiting for that to complete. Now, while you see this, I'm going to paste this next command. You can see that it's actually giving us a message here that instances on this network will not be reachable until firewall rules are created. So I mentioned earlier, traffic is allowed if firewall rules allow it. Right now, there are no firewall rules. So in the next section, we will set up firewall rules. This actually gives us some pretty useful commands on how to create these, but we have them in the lab instructions as well. So we will be leveraging them from there. So I've created the networks, and I can actually go in here now and ask for the networks to be listed using the gcloud compute networks list command. So when I run that, you see that I have 4 networks, 2 are auto and 2 are custom. And I can also actually list all these subnets and sort that by the network. So here we see we have all of these subnets from the default, which is auto mode, so 1 subnet per region. The management network with its subnet that we just created, the my network, which is already created for you, and private net and its subnets. All right, so we've created the networks, so now it's on to creating the firewall rules. I'm going to go navigate back to the console. So here's the console, and I can close this terminal. And if I refresh this, by the way, and collapse these, we can also see the 2 networks that we just created along with the subnets. So firewall rules are over here on the left-hand side. So I'm going to click that. And I'm going to start again by first creating a firewall rule console, then Cloud Shell. So in here, I click on create firewall rule. And if you see here, we see that we already, I can collapse that. We already have a bunch of different firewall rules, and we see the networks. And you see that we only have them for default and my network. So again, no firewall rules were created for the custom mode networks to be created. That's important because you don't want someone to just create automatically firewall rules for you. You may not want them. So let me click create firewall rule. Give it a name, again, from the lab instructions. Now, very important, I need to select the network. This is from management net. I'm going to define that this applies to all instances in the network. It's just for simplicity for now. And then for the IP source ranges, I'm going to say that we are going to accept traffic from everywhere for now. Okay, this is just for testing purposes. You will probably want to narrow that down a little bit on your end, but this is just so we can test this very easily. Now, importantly, I also need to specify the protocols and ports. So I'm defining a firewall rule to allow ICMP, SSH, and RDP. So ICMP, I just say other protocols, ICMP, and then SSH and RDP, I can just put in here like that. Those are the ports for the TCP protocol. Now, if I keep scrolling, again, I'm presented with the command line option. This is just one command. It's a firewall rule. The project is, again, by default. You don't have to define that. So the command is gcloud compute, firewall rules, create. The name of the rule, the direction, and priority are also default values as well as the action. So I really just have to give it a name, define the network, define the rules, and the source ranges. So we'll see that in a second. Let me click create. And then I'm going to go back to Cloud Shell. I'm going to clear this up here a little bit and run a similar command to create the exact same firewall rule for my private net network, and obviously with a different name. So you can see I can actually do these things in parallel, which is definitely useful if you want to speed up your points. But I actually recommend figuring out all of the gcloud commands and running all of them. If you stay until the end, I'll even give you one tip that will make all of this even faster. All right, so we've created the network, we've created the firewall rules. I can again query the firewall rules. So if I go in here, gcloud compute firewall rules list, this is the actual action verb, and then sort by network, I will be given all of the firewall rules. So we see the default and my network had rules already for ICMP, RDP, SSH. They just had them in separate rules. You can clearly, as we just showed, combine multiple ports and protocol combinations into a single rule. So we see those are good. And if I come back here to the console and refresh that, you can see as well now, if I scroll a little bit to the left, to the right here, that we have a rule for private net and a rule for management net. And you have all the information that we just specified. All right, so now it's time to actually create our instances. So let's use the navigation menu and move to Compute Engine. And the first thing you will notice is that if I close this panel over here, that MyNet EUVM and MyNet USVM have already been created for you. Now, if you just look at this view by default, it's actually kind of hard to tell what network these are part of. So I think it's really critical to go over here to Columns, scroll down, and click on Network. And that's going to show us that these both instances are actually part of my network. Great. So now we're going to create some instances. So I'm going to click this button up here, which says Create Instance. Again, you want to follow the instructions exactly. I'm going to give it the name Management Net USVM. We want that to be in US Central 1, and specifically Zone C. I'm going to change the machine type. The lab is telling us to use an F1 micro. And if I just did this, it would actually create it in the default network. So it's very important for us to scroll down, expand this section, click on networking, and change the network interface. So I'm going to click on this and change the network to management net. That is the network I want to create this in. Now you see it automatically selects the subnet. It knows the subnet because of the region that I created the subnet in. This is the only region that exists. If I had multiple subnets in that region, then I would be able to choose between them. Pretty simple here. Now I'm going to click Done. And again, I'm presented with the command line. So if I click on the command line, this is really long. Again, a lot of default settings in here, like the image, the project. The real important things are the name of the machine, the zone, the type, the subnet. So really just kind of this first set of information here. You'll see that in a second. So let's create this. And then we're going to create our other VM instance using Cloud Shell. So let me switch to Cloud Shell. G-Cloud Compute Instances. Create is the action. Private Net USVM is the name. I give it the zone. The type, we're actually doing a different machine type in this case. And then the subnet is private subnet US. And there it is. The machine has been created. I can list all the machines and sort them by the zone. And here you'll see that out of the 4 machines, 3 are actually in the exact same zone. Now, these 3 are in different networks though. So if you remember what I said earlier, we will not be able to just by default ping these VM instances on their internal addresses, even though they're in the exact same zone. And that is because they're in different VPC networks. And these networks are isolated by default. So let's actually go ahead and explore that. I'm going to go back to the console. And here you can see all the instances. And here on the right-hand side, you see also the fact that these are, except the 2 instances already there, the other 2 I created are in different networks. So we're going to explore the connectivity here. And we're going to be using both the internal IP, which we have in this column right here, as well as the external IP. Now, if I scroll to the right-hand side here, there are actually buttons over here that let me SSH, and that opens a new window. But I want to show you a different way that you can quickly SSH as well from Cloud Shell. So first, I'm going to SSH to MyNet USVM. So let's go to Cloud Shell and run the command gcloud compute SSH and then the name of the VM. All right, so it's telling me that I don't have a key. If I want to continue, I can create a passphrase. I'm just going to hit enter and enter. This is just for demo purposes. It's asking me if it's the machine in US East 1B. No, it's not. I don't actually have that VM in there. So I'm just going to click no. I could have also specified the zone, but it's saying, hey, okay, I know what you mean. There is no machine. Instead, it's in US Central 1C. So I'm going to use that instead. Now, the command prompt has changed. Up here, my command prompt said add Cloud Shell. Now the command prompt says at the VM. So I am now SSH'd into this virtual machine through Cloud Shell. So in here, we want to ping a machine. So I'm going to run the ping command. And I'm going to use the external IP address of my net EU VM. So let me grab that. I can click on this button to copy that to my clipboard and run that. And that works fine. I mean, that's expected. I have the right firewall rules in place, so I should be able to do that on the external IP address. Let's try the same thing for our other VMs on the custom mode networks I created. So first, I'm going to go to Management US VM, grab the external IP, paste it in there. And that also works, again, expected. And then I'm going to do the same for private net US VM. And that works as well. So that just means I've set up the firewall rules correctly to allow this kind of traffic. Now we're going to switch things up a little bit. Now we're going to ping the internal IP address. So I'm going to run again ping 3 times. But this time, I'm going to be selecting the internal IP address. So let me start with my net EU VM. This is in the same network, but in 2 different regions. Oops. And I've given the ping command incorrectly here. Need to remove that dash and put it before the C. All right. And that works, right? This is expected. We're within the network, even though we're in 2 different global locations. Now, what shouldn't work is if we try the same and put in the internal IP addresses from management net and private net. So if I click here, the internal IP from management net and paste that in. It's not really working. All right. In the meantime, I can grab the address of private net. We can wait for this to time out. It takes about 6 seconds. Here we go, 100% packet loss. And also try this other IP. And this shouldn't work either. So this is all expected. Now, let's make this interesting. We're now going to go ahead and create a VM instance with multiple network interfaces. This is what I talked about earlier, right? Where you have multiple NICs. Each of the NICs is going to live in one of these 3 VPC networks. You can have actually VMs with up to 8 interfaces. For that, though, you'll have to choose different machine types. It's all documented in the lab. But let's go ahead and create the machine. I'm going to clear this out. And we're going to do this from the navigation menu. Over here, go to VM instances, create instance. And this is going to be our machine called VM appliance. So I'm going to give it a name. We're again going to put it in Unicentral 1C. And now we're going to change the machine type to use 4 virtual CPUs. This is important. 4 virtual CPUs give us actually 4 network interfaces. And again, the lab has more information on this requirement. And then I'm going to scroll down because I need to create these actual interfaces. So I'm going to expand management security, this networking. Click on networking. Now, I don't want any of this to be in the default network. I could have actually deleted it. I don't need the default network at all for this lab. And instead, as the first network, we're going to choose private net. And that actually has some importance later on that we'll talk about. So let me select private net. And now I'm going to add a network interface and select management net. You can see it automatically gets its internal. It also has an external. I mentioned it doesn't have to. You could actually get rid of that. And last but not least, we're going to add my network and then click done. Now, important, you probably want to also look at the command line here. There are some default values in here that you may not need to use, but this is quite interesting to look at so that you can also configure this virtual machine with all of its multiple network interfaces. All right, just want to confirm that otherwise we're completely set up. I want to just make sure we have the right operating system. Okay, for some reason that was empty, so I like to just review that, make sure we have the right virtual machine, we have the right name. And okay, so let's go ahead and create that. So who's going to create the virtual machine now? And what we're going to do first is actually explore this machine a little bit more. You can see that next to each of the individual instances here, it says NIC 0. And if I click on an instance, let's actually do that for the VM appliance, I get to the network interface details. So NIC 0 is private net. That is the first one I attached. It tells me the internal IP of this instance on that network, the external IP. It also gives me some more information about the instance, as well as the firewall rules that apply to this instance. Remember, I set the firewall rules to apply to all instances in this network. I can get the same information for NIC 1, different IP address, different network, subnet, different firewall rule, and NIC 2. Okay, so you have all of that different available. So let's go ahead and let's actually now go into that virtual machine. So if I go back to Cloud Shell, I am still SSH'd into MyNet US VM. So first, I want to exit that. Then I'm going to run the same command to SSH, but now for VM appliance. It's asking me if it's in US East 1B. It's not. So I'm telling it no, and it figures out that there is one in US Central 1C. So it is now going to SSH into that instance instead for us. And once we're in that instance, we can actually look at ifconfig to look at the different network interfaces, and we'll see the different networks that is connected to. And then once we've done that, we're going to go ahead and explore the network interfaces connectivity. So we're now going to again ping, but this time we are not going to do the external IP addresses. We know those work. We're just going to do the internal. Looks like this timed out. I just created the machine. That's not unheard of. So let me just try that again. And there it worked. So I can see here after the @ it says VM appliance. So I know I'm in the right place. And if I run sudo ifconfig, we'll see the different ports here that we're on. So this is one of the networks, here is another network, and here is a third network. So you can actually look those all up directly from the instance as well, because the instance needs to know about its network interfaces. All right, so let's go and ping some instances. So first, we're going to go ahead and ping the same instance that is in the default network interface, that is NIC 0. NIC 0 is private net. So if I go back to the console, I'm going to grab the internal IP of private net US VM. So I'm going to copy this, paste that in there, and that works. That's expected, right? I'm in the exact same network. We can actually take this a step further. Instead of using the internal IP, I can actually use the name of the instance. So let me copy the name. And that works as well. And you're able to ping private net US VM by its name because VPC networks have an internal DNS service that allows you to address instances by their DNS names rather than their internal IP addresses. And when an internal DNS query is made with the instance host name, it resolves to the primary interface, which again is NIC 0. Therefore, this actually only works for private US VM. If you tried this for names of other VMs in these other networks, this would not work. Now, we're also going to try to now ping the other network interfaces. So let's get the machine from the management network and use its internal IP address. And we can ping that as well. Great. And let's try the same for MyNet US VM, the internal IP, which was NIC 2. And that works as well. And then last but not least, let's try MyNet EU VM. And I need to get that internal IP. And this actually doesn't work. That's for a reason. In a multiple interface instance, every instance gets a route for the subnet that it is in. In addition, the instance gets a single default route that is associated with the primary network interface, which is ETH0. So unless you've manually configured routes otherwise, any traffic leaving an instance for a destination other than the directly connected subnet, because remember, the network interfaces are connected to a subnet, the traffic will leave the instance via the default route, which in this case, we can look up IP route, we can see that the default is leaving right through here, which is private net. Okay, so that is technically the end of the lab. I do want to give you that one bonus tip. So we've done all of these different steps now. We've used the command line quite a lot, and you can certainly do that more. But there's one way to do all of this actually quicker. To just create all of these different resources and get all the points, you could also use Deployment Manager. Now, I've actually used Deployment Manager for you in this lab. If I go to the navigation menu and scroll down to the Deployment Manager service, which is pretty far down. So I went past it. Let's see, there we go. You can see that we've already run Deployment Manager for you, and that was to create the My Network, its firewall rules to allow SSH, RDP, and ICMP, and the 2 instances. You can actually see this when you open your lab, and you can get the Jinja, which are the templates, as well as the configuration file for this. And you could technically modify this yourself to create your own configuration to create all of the resources that we just created, so that when you spin up the lab, you literally come in, you go to Cloud Shell, and you directly deploy your Deployment Manager configuration. Now, that task certainly takes a lot more tinkering. It is a lot quicker to just use Cloud Shell, but the actual speed of execution will be faster because Deployment Manager will create these resources in parallel for you. So again, just a little extra tip for you there. And that's the end of the demo. So I hope you learned a lot from that lab. Let's get back to the slides. Now, this lab is part of one of our newly launched skill badge quests on Quick Labs. To explore more about skill badges, visit the link on the left, which is cloud.google.com/training/badges. And that is it for a Cloud on Air webinar. My name is Philip Meyer, and I hope you enjoyed the session, and I thank you for attending.